Okay, dear students, welcome back. How are you on? Are you enjoying your studies or not? If you start enjoying your studies, then no one can stop you from passing and becoming successful. Because most people feel that studying is a punishment. If it feels like a punishment, then brother, it will be very difficult and you are bound to get punished. Because the one who feels it's a punishment has to give more attempts. The one who enjoys it passes quickly. This is the loop for those who feel it's a punishment, and the ones who enjoy it move ahead. Alright. Remember this in life, the work you enjoy from the beginning, you will enjoy doing that work more. If any work starts to feel like a punishment, it means you're going to get more punishment in that work. Fun leads to more fun, punishment leads to more punishment. Anyway, let's move ahead. Today we are starting with linear programming. So in linear programming, we won't be doing everything that's given here. We'll only work on formulation, alright? In the Institute's material, along with formulation, both graphical solution and simplex solution are given to us. We are only going to work on formulation. So we are focusing only on whatever is given in the Institute material. So right now, let's look at the first illustration here. Before doing the formulation in every sum, we first tabulate the data. So what is being said here? The shopkeeper deals in two items, wall hangings and artificial plants. He has 50,000 rupees to invest and space to store at most 100 pieces. He has 50,000 rupees, can keep 100 items, wall hangings, artificial plants cost 450 rupees, 200 rupees. For wall hangings and artificial plants, their cost per unit are 450 rupees and 200 rupees respectively. He can sell a wall hanging at a profit of 80 rupees and an artificial plant at 37 rupees. So, 80 rupees for this, 37 rupees for that. Assuming he can sell all the items he buys. Formulate a linear programming problem in order to maximize profit. Data giver. The total cost he has is only 50,000 rupees and the combined storage space for both items, let's say X for one and Y for the other. Together they can store only 100 units. Alright, so the maximum total space is for 100 units. Most means maximum. So, the first step of every sum is that way. I'm saying diagram, but by making a tabulation, by making a table, we should first write the data in whatever order we want. We just want to write the data first, that's it. We want to write down the data first of all. Now, according to this, what will we do? Based on this, we will do the formulation. The golden rule of formulation is that first, think about the objective function. The thought process says, what is the objective? Maximize profit. If the objective is to maximize profit, then figure out what needs to be done to achieve that profit. Whatever needs to be done, that will become the variable. So, the profit will come from these two. So the variable will be the units of Vari wall hanging and artificial plants, which are X and Y. Units of wall hangings and artificial plants, which are X and Y. Alright. Now, according to this, the objective function will be formed. The objective function is maximize Z equals the total profit, which will be 80x plus 37y. What will you say for 80x plus 37y subject to? All the constraints will have to be included under subject to. In the constraints, two constraints are visible. One is for total investment, which is 450x plus 200y is at most equal to 50,000. At most means less than or equal to. And the second constraint we can see is that the space we have is 100, so x plus y is less than or equal to 100. And third, without saying anything, we have to apply the non-negative assumption, which is x, y greater than or equal to 0. X, y greater than or equal to 0. Is it okay? So this is the formulation, and this is what you have to conclude and present. Now, to solve this, there is a graphical method and there is a simplex method which has been mentioned here. But we are not learning that because, till now, it has never been asked in the exam. Alright, even if it comes in the 2022 syllabus, we would still say to leave it. You just need to do the formulation part. Otherwise, attempt another question from the options. Because doing all that will take up a lot of your time and we are not learning simplex right now. Alright, because in the 2016 syllabus, it was never asked and it was specifically mentioned there. In this syllabus, it is not specifically mentioned, and even if a few sums are given, we are still not doing them. Assuming that since it was not asked earlier, it won't be asked now either. Thinking like this, it shouldn't come in the exam. Now if it does come and our luck is bad, then just skip it in the options. Then we'll see later whether we will cover it in the next attempt or not. What is illustration to saying? A dealer of cement has to warehouse with stocks of 30,000 and 20,000 bags of cement respectively. 3 customers have placed orders on the dealer for 15, 20 and 15,000 bags respectively. The cost of transportation per bag in thousands per 1,000 bags is given below. From M and N, warehouse M and warehouse N, the transportation costs are provided. This is a transportation sums problem. The dealer wants to fulfill the order so the transportation cost is minimum. The objective here is given as P. Formulate the problem. It asks for the formulation of the transportation problem. For the formulation, the basic rule is to do tabulation. Here, a table has been made for tabulation. So, you will copy this very table in your solution as a working note, and then the quantities given here for the warehouse capacities are 30,000 and 20,000. And here, we have the availability. That is 15,000, 20,000 and 15,000. Alright, so availability actually means requirement here. I shouldn't have said availability. I should have said requirement. Capacity means availability and this is demand. That is, it is the requirement. This is their demand. Alright, placed order means this is their demand. So how do we proceed further from here? First of all, we need to do tabulation. Step number 1 is tabulation. Step number 2, we need to find out. If you want to write step number 1, then do the tabulation. Step number 2, we should find out. What is the objective? So, our objective is to minimize the cost, to minimize the transportation cost. So, you can say it like this. The figures given for transportation cost, those will be the variables. Similarly, the profit figures given above, those many variables will be there. There are 2 variables to profits. Here, since there are so many transportation costs, that many variables will be there. Since there are so many transportation costs, there will be that many variables, so step number 3 is to think about how many variables will be there and what they are representing. Since the transportation cost per unit is given, let's assume it is x1 or x2, x3 and so on. This could be x4 or x5 or x6. In this way, we have 6 variables. So, in this way, we have got 6 variables. How many variables are there? There are 6. So, how many variables are there in total? There are 6 variables, so step 1 is done. Step 2 is done, and step 3 is done as well. You have understood step 1, step 2, and step 3. After this, now it begins. When it begins, first of all, we say that you have to write the objective function. What is the objective function? Minimize transportation cost. Minimize transportation cost. Alright, now what will be the total? Z equals, you will have to make all this. 40x1 plus 20x2 plus 20x3 plus 20x4 plus 60x5 plus 40xx to find the total cost. Then, the subject to constraints will be added. How many constraints are there? That will have to be written. So, in the constraints, you can see that one is for capacity and the other is for demand. And if there are two warehouses, then there is a capacity restriction, so we will write the capacity of the warehouse. What is happening in M? If we add up all three for the three people X, together they do not have more than 30,000, so it will be less than or equal to 30,000. Similarly, write for N as well, X4, X5, X6, you say it yourself. If you are writing along with me right now, that's good, otherwise you say it now. Alright, you can write it down comfortably later. Right now, if you are working along with me at this speed, then do the work when I tell you and do the calculations when I show them. What will be the requirement? Warehouse A's requirement is that the sum of X1 and X4 should be at least 15,000, so greater than or equal to 15,000. What about B? What is X2 plus X5 equals 20,000 C? X3 plus X6 together should be 15,000. If you have understood, your requirement is set and you must include the non-negative assumption by default. Say greater than or equal to 0, where I is from 1 to 6, this is the shortcut. Otherwise, you must write X1, X2, X3, X4, X5, X6 one by one, each greater than or equal to 0. Now, if you look at the solution here instead of your or my solution, you won't understand what has been done, so leave it. Do it like this, it's the accepted solution. See a similar example in transportation chapter, done this way. Sometimes it happens that instead of writing greater than or less than equal to, the institute writes equal to. So, even if everything is written as equal to, it will still work. Alright, so both are correct. Even if you just put equal to, it will still work. Yes, even if you only use equal to, it will still work. But what is more appropriate? Capacity means the maximum required and demand means. This is the minimum required, so normally, for example, if you give 15, 20, 50 from here and 50 is coming from there as well, then why should we put less than the basic amount? So, equal to can also be appropriate. Using equal to can also be appropriate as we will neither put less nor just the basic amount. For a general idea, greater than and less than can work here. But equal to a little more is a precision. In a way, equal to is also valid, so you can write equal to, there's no problem. Alright, so this was also a formulation. But this was from the transportation angle. So, whoever has a doubt in this can mark it with a star. We'll keep making a list of the questions where we are getting stuck, so that I have a separate list of such questions which we can revise again later. Alright, let's move to the next question. Look at illustration 3, what is in this? It says to solve using the graph. But as I told you, we are ignoring the graph part. We are only working on the formulation. If a graph comes in the exam and I have taught it in class, then you can do it accordingly. If I haven't taught it, then I don't remember. If I haven't taught it at this moment, then just leave it. You can only come by formulating it or skip this question. We cannot spend time learning the graph or using the simplex method. See what it says, formulate it, try it yourself. If you want, pause the video and try it roughly. Then move ahead. So, what is it saying here? One kind of cake requires 200 grams of flour. So, the flour is 200 grams and the fat is 25 grams, so this is one kind of cake, cake 1, and another kind of cake. So, cake 2 requires 100 grams of flour and 50 grams of fat. So, from this, it is asking us to find the maximum number of cakes that can be made from 5 kilograms of flour. These are in grams, okay. It is saying we have a total of 5 kilograms, so 5 kilograms means 5,000 grams and 1 kilogram of fat, so 1 kilogram means 1,000 grams of fat. This is available. Assume there is no shortage and here nothing has been mentioned about cost, etc. The point is saying the maximum number of cakes. So, we have to maximize the cakes. Alright, there is no cost or profit involved. But since we have to maximize the cakes, just make the number of cakes your variable, x and y, and this is what we will maximize. So look, first of all, the thought process says objective tabulation. Step 2 says that you should find the objective, which is to maximize the number of cakes, and step 3 says to assign a variable to whatever will help you achieve that objective. So, we have made the number of cakes as a variable. So if these 3 steps are done correctly, then it becomes very easy. Now the formulation will start. In the formulation, you will write the objective function. What will you write first in the objective function? Maximize z equal to, we have to maximize the number of cakes, which is x plus y, subject to constraints. What will come in the subject to constraints? Number 1, 200x plus 100y less than or equal to 5000. Number 2, 25x plus 50y less than or equal to 1000. Number 3, x, y greater than or equal to 0. Done. If you want, you can also mention the names, whether it's for flour or fat, but it's not necessary. You can also directly write the answer like this, comfortably. Is it okay? Let's move on to the next question. Yes, again, in this one it's solved using the graphical method. But we will not solve it. We will only learn the formulation. Mr. Lal is on a low cholesterol diet. During lunch at the office, he always chooses between 2 particular types of meals, type A and type B. The table below lists the amount of protein, carbohydrates and vitamins. Each meal provides along with the amount of cholesterol which he is trying to minimize. So, we have the objective, which is to minimize this. He needs at least 200 grams of protein, 90-60 grams of carbohydrates and 40 grams of vitamins for lunch each month. So, we see protein, carbohydrate, vitamin and cholesterol. How much does he need at least? At least means a minimum of 200 grams of protein, 960 grams of carbohydrates and 40 grams of vitamins are required. Then after that, it is saying, over this period, how many days should he have type A meal and how many days should he have type B meal? So that he gets an adequate amount of protein, carbohydrates and vitamins, and at the same time, cholesterol intake is minimized. So the objective is minimization. So tabulation has to be done, and here the tabulation is already done, so we didn't have to do it here. Minimization of the objective, minimization of cholesterol, so the objective becomes the variable. So, what are the variables? They are x and y. What are the variables? X and y will be the variables. What will be the variables? X and y. So, according to this, you can do your formulation. The formulation will be minimize z equals 60x plus 50y. The variable is x and y is the number of miles in 1 mile, okay. The question asked, write how many days you should have type A and how many days you should have type B meals. So basically x is, you can say x is the number of meals or you can say x days. You can also call it the number of days. In a way, x days of type A meal, y days of type B meal. You can say number of meals like this. In one, we take 1 day. Number of meals and days are the same. So, from one meal, you get this much, 8 grams, 60 grams to grams. So you can understand how much you will get in total from X meals. Alright, and if you are getting 60 milligrams of cholesterol from one meal, then how much total cholesterol will you get from X and Y? After this, it will be subject to constraints. In the constraints, number 1 is protein. Protein will be 8x plus 16y minimum, that is, less than or equal to 200 minimum. Minimum is greater than or equal to, you need at least 200, meaning it should be greater than or equal to 200. Second is carbohydrates. You tell me yourself. For carbohydrates, 60x plus 40y should be greater than or equal to 960. Tell me the third one for vitamins. For vitamins, 2x plus 2y should be greater than or equal to 40. And number 4, what will be the non-negative assumption? X and y should be greater than or equal to 0. Non-negative assumption x gum be equal to 0. It's done. Now we can solve this. Solving it is also kept outside our scope. If it comes in the exam, we will just formulate it and leave it. Once solved, I have to leave it. Meaning, you can do half if you don't find it in any other option. Alright, only do as much as I am teaching you. Right now, don't take any extra load. Come to the next illustration 6. So here, what is being said to us, the firm manufactures and sells two products, alpha and beta. So look, we can do the tabulation by reading each line one by one as well. Alpha and beta, the products, we usually put them here. Then, each unit of alpha requires 1 hour of machining, so machining is taking 1 hour. 2 hours of skilled labor, so skilled labor takes 2 hours. Whereas beta uses 2 hours of machining and 1 hour of labor. For the coming month, the machine capacity is limited to 720 hours and skilled labor is limited to 780 hours. So this capacity means this is the maximum available, which we know. Not more than 320 units of alpha can be sold in the market. One more thing is given here, the maximum units of alpha can be 320. Alright, develop a suitable model that will enable determination of the optimal product mix. Suitable model basically means we have to do the reformulation. So, it says optimal product mix here, but it hasn't mentioned yet whether we have to maximize or minimize. Alright, read further. It is written here, determine the optimum product mix and maximum contribution if the unit contribution from alpha is 6 and from beta is 4. So, I have got the contribution per unit here as 6 and 4. The word optimal means either minimizing cost or maximizing profit. So, since we have got the details of contribution, we will go for maximizing contribution. So, our second step is complete as we have identified the objective. The third step will be to identify what the variables are. The variables will be as per the contribution given. So, x and y will become your units of alpha. Alpha and beta, so those have become your variables. Keep these 3 steps in mind: tabulation, finding the objective, and identifying variables. Now, what do we have to do after this? We have to formulate it. Here, the contribution for the optimal product mix is given. So what will we write as the objective function? We will write the objective function. Try writing the objective function yourself. Give it a try. The objective is max z is equal to 6x plus 4y. Instead of x and y, you can also write x1 and x2. Subject to constraints, what are the constraints? There are 3 constraints. One is related to machining, which is x plus 2y less than or equal to 720. Second is skilled labor, 2x plus y less than or equal to 780. The third one is the maximum sales of alpha, which is 320. So, how much will that be? The maximum value of x can be 320, so x is less than or equal to 320. Number 4 is the non-negative assumption, x and y are greater than or equal to 0. Understood? It's very easy. Alright, the formulation is complete. Let's move ahead. If you are asked to reformulate as per simplex, then to solve it using simplex, I can just tell you one step, that you need to reformulate it. In reformulation, different types of equations are handled in different ways. Right now, I am only explaining the less than or equal to type. So, to reformulate the less than or equal to type, the simplex table or simplex method says that if you bring the equation in the equal to form, only then will I be able to solve it. So, if you bring it in the equal to form, there is no problem with max z because it already has an equal to sign. Now, where do I bring the equal to form from in the subject to part? Mine is less than or equal to, so x plus to y can also be less than. Our rule says it can be less as well, but simplex says make it equal. It says make it equal to 720. So, since it can be less, to make up for that, we introduce a new variable. That is called a slack variable. Slack variable. In one inequality, one slack will come. Here, only one slack will come. Similarly, in the second will come. In the third will come. In one inequality, only one slack can come, so S1 came. In the second one, put 2x plus y s plus s2 equal to 7, 8. Then put x plus s3 equal to 320. Alright, when writing non-negative, you already write x and y. Also write s1, s2, s3 as greater than or equal to 0. You write x and y, so also write s1, s2, s3 as greater than or equal to 0. Also, write plus 0, s1 plus 0, s2 plus 0, s3. You must include this in the objective so the slack variables do not affect the objective. We introduce slack variables only as a requirement for the simplex method, and we nullify their effect in the objective. That's all you need to know for the simplex method. The simplex method actually starts only after this. We haven't even started the simplex method yet. We have just learned how to reformulate the problem according to the simplex method. Let's move ahead. We are not looking at all these solutions. You don't need to think about this. This question is made entirely according to the simplex table, so you don't need to think about this either. Come to illustration number 8. See how the formulation is in this? The formulation here is a bit unique. 3 products x, y, z are being made from a common material. However, the proportion in which the products are produced is different in each plant, and so are the plant operating costs per hour. Data on production per hour cost is given below, together with the current orders in hand for each product. So we have products x, y, and z. We have plant A and plant B, and the orders on hand are given, showing how much order has been received for each product, and the operating cost per hour of each plant is also given. All right. You are required to use the simplex method. It is saying to do it using the simplex method, but I will only teach the formulation. You have to find the number of production hours needed to fulfill the orders on hand at minimum cost. So, normally when such data is given in the question, it asks how much of each product needs to be produced. But here, it asks how many production hours are needed to fulfill the orders at minimum cost. The question is reversed. That's why the objective here, the entire tabulation has been done. The objective is to minimize cost flow. What is it? Think about it, the tabulation. Then find the objective. The objective is to minimize cost, so the minimum cost is given here. To represent this, the variables will be x and y, x hours and y hours. Whatever sound we want to produce becomes the variable. So, the variables are chosen as x and y, now it is in terms of hours. Now, we will formulate it based on this, which will be minimized z equal to 9x plus 10y. We have to do it. Then what do we have to do next? Subject to constraints. In this, there is plant A and plant B. So, what will happen in plant A? See, 2x2 into x plus 4 into y. Alright. What does this mean? What are 2 and 4 for? What is 2 and 4? How many units can be produced? The proportion of products produced in each plant. How many units can be produced? And together, we need at least 50 units. Orders on hand are 50, meaning we need at least 50. This is the minimum requirement. What is observed? This is a minimization problem, right? In such cases, the constraint is greater than or equal to. And in maximization problems, the constraint is usually less than. So, from this, you can get an idea in your mind whether the flow you are thinking is correct or not. 4x plus 3y greater than or equal to 24, and what about C? I am writing plant. Sorry. Here, the products will be x, y, and z. What will be the value of z here? 3x plus 2y greater than or equal to 60 and subject to the non-negativity assumption, which is x, y greater than or equal to 0. In a way, this problem has been created from the opposite angle. Till now, the problems that were being created above were from the angle of x, y, z from the product's perspective. We were looking at the product from the angle of maximizing profit and observing that plant A was also acting as a constraint. What has happened right now? Plant A has also come in as a variable now. It has started playing the role like a product, and the product is now playing the role of a constraint. So, when the scenario is the opposite, it is called the dual of the primal. The original problem is called the primal, and the opposite scenario is called the dual. So actually, we did not create the opposite from our side. But this question, in general, is of the opposite type, so in a dual type question, normally the resources in the constraints are considered valuable in the dual. The resources in the constraints are considered valuable, so we try to find out the rate of that valuable resource, or sometimes the awards are not given here. Here we find out about the awards, or else we find out the rate. What is the rate of this constant? It is called dual. When we try to find out the rate of the constraint, it is called the dual. I will show you about the dual as well when it comes below. So, in the dual, we think of the opposite scenario. For example, when it was about the product, the constraint for the product's profit was the plant, usually the department, so that is the primal problem. So, the dual of that problem would be to find out what should be the rate of the plant's limited resource so that our objective, which is the requirement of the product, gets fulfilled. That is what we call the dual. It is made from the dual's perspective. If you people are not going to solve it, then just leave it. So sir, if this comes in the exam, what will we do? We won't solve it. If you know how to solve this question, then go ahead and do it. I am not teaching this right now. Isn't it? Now look, this has come to the next dual. Questions from dual come in the exam, so learn the dual. So what is the basic idea in dual? Just understand one basic idea, that the original problem, the one that is given, is called the primal, and a reverse view of this is made, which we call the dual. What I was just explaining above is that if we have products X, Y, Z, and to make them they will go through plant A and plant B, and we know the contribution per unit for X, Y, Z, then what will we want? We will want the contribution of X, Y, Z to be maximized. But the capacity for this is given to us in ours, so this becomes a constraint. Alright, so the sign for a constraint is like this. If we are talking about capacity, that is. And what do we say for maximizing? For maximizing, we will say Z equals whatever value of Xij is coming, that is subject to, what do we say? Subject to, we mention the constraints. So, what will be the sign for the constraint? It will be less than or equal to, and in the end, we will mention the non-negativity assumption. That will be X, Y, Z should be greater than or equal to 0. X greater than or equal to 0, Y greater than or equal to 0, Z greater than or equal to. Now, if we put this into the dual says, you have to look at the opposite angle. The dual says that when you were thinking about maximizing Z, you were considering it from the product's angle. But you should also understand the resources you have are limited. These are valuable resources, so why not rent them out? That way, you will also earn an income. Yes, it will definitely come. So, what should be the rate of that income and what should be the rate for that income? So, let's assume U1 and U2 are the rates. Assume this is the rental rate. This is the rate per hour, so we are making the rate per hour a variable. In the previous question, the rate per hour was given, so we made the hours variable. But here, we are making the rate per hour variable, and since we don't do this business regularly, we will find out what the minimum rate should be. To find out what the minimum should be, we will say minimum Z equals the total rent should be covered by multiplying whatever the capacity is with this. For those plants which are the limited resource, since the resource is limited, their rent should also be recovered. So, if there are limited resources, then rent should be received and the amount of rent that should be received will be calculated by adding this into this and the total rent will be calculated from this. From this, the total rent will come, and what do we have to keep in mind as the subject to? There will be a subject to constraint, which is what will be the subject to for X and Z. There will be a constraint for X, I and Z, alright. What will be the subject to? There will be a constraint for X, I and Z. And what will that constraint be? We should know that if we do not rent out this resource, if we do not put this resource on rent, then we would have given this resource to product X and earned some contribution from it. And if we do not rent this out, we would have given it to product X and earned some contribution from that as well. So if we are going to rent it out, we have to keep in mind that there is an opportunity at home where we can see how much contribution we could have earned. So, accordingly, we include this in the subject as a constraint that we should at least get the minimum amount that we are already getting from the contribution. Suppose here it is 5 rupees, 5 hours here, 2 hours here and 20 rupees for example. So what will we say as the constraint? 5y1, what's my y1? Y1 is the rate per hour that we recover from plant A. If we rent out plant A, we will get y1, so y1 into 5 hours is the total rent from 5 hours plus to y2, which is the total rent from plant B for 2 hours, and together these 5 and 2 should at least earn 20 rupees, so at the very least 20 rupees should come in. In the same way, the second constraint will be formed and then the third constraint will be formed. If it is an XY seat, then it will be an XY seat. Are you able to understand anything? If the normal sum is primal, then its opposite view is dual, alright. Now, the normal sum is not always the maximization one, it can also be the minimization one, so its opposite view is dual. Dual is the flipped view of the same problem, so how do we think about it? If you think from this angle, it will be easily understood that if we are selling 3 products, maximizing their contribution, and our constraint is the plant, then since there is a constraint, we can also earn something by renting it out. So, what should be the rent? That can be found out from the dual. So if the rent is made a variable and we try to find out what the means add is from that, can we find out what the means add is? Can we find out what the means add is from this? Tell me, can we find out what the means add is from this? So, it was found that the means add is this plus whatever this is. Now, considering these, you might ask why means and not rent max? This isn't a business for this, so we are considering the means. Before applying it to rent, we must check if the opportunity exists. Since we are already earning 20 rupees, we need to earn at least that much. So in this way, you make the subject the constraints here, and then you also put your own non-negative assumption for U1, U2. Alright, I have given you an idea from primal to dual. If this concept is set, then you will have to understand one theory that if you are asked to do dual for a maximization problem, alright, then a maximization problem has a feature that all its constraints should be of the less than or equal to type. If it is not like that in the question, then you will have to make it so by changing its sign, and if there is an equal to sign, then it will remain as it is. Equal to sign. it will remain as it is. Meaning, here the sign of the constraints should all be less than or equal to. This is the condition. If not, make it so. If there's an equal sign, it stays. No problem. An equal constraint can also come, so that stays too. So basically, if you ignore the objective and just think about it, the sign of the constraint in a maximization problem is like this, and there are also non-negativity assumptions. Its sign is normally called non-negative, meaning it is greater than or equal to, and sometimes in the non-negativity assumption, it can also be mentioned as unrestricted. What can it say? Unrestricted? Till now, you haven't come across this above, but in such problems, it can happen that it is mentioned as unrestricted as well. So, when we make the dual in a max problem, suppose the dual is on this side, on the right side, then just notice this thing, the sign of the non-negativity assumption. The greater than or equal to sign will remain the same here. When we come to the dual, in the dual, the max problem will become a problem, and I gave a basic idea that the general sign of the problem in its construction is the greater than or equal to 1. The general construction sign for a max problem is less than or equal to. So, in a max problem, less than or equal to is given in the constraint. If greater than or equal to is given in the non-negative assumption, then when it goes to the dual, keep that in mind. This sign will be used in the constraint, and you will get the greater than or equal to sign in the construction because the dual is minimization. The standard sign for minimization is greater than or equal to, so it will remain the same, and when there is a non-negative assumption in the dual, you should understand that its sign is greater than or equal to. What is the sign for non-negativity? It is greater than or equal to 0. That's why it's called non-negative. So here, if you are given less than or equal to, then its opposite sign will come here. In the OP, the opposite sign will come. If it's less than or equal to, the opposite sign will come. If you are given equal to, if the constraint with an equal to sign is given, that is also allowed. A construction with an equal to sign is allowed. If it is equal to, at that time unrestricted will come. Here, we will say unrestricted. In the same way, if unrestricted is given here, then here we will say equal to. If both are same and unrestricted, then equal to comes, and if it is equal to, then unrestricted comes. Remember this in reverse. If it is equal to here, it will become unrestricted here. If it is unrestricted here, then there it will become equal to. Now, if we solve it with this, you will understand. Now, what has been done in the minimization problem? See, the condition for the minimization problem says that all your constraints should be greater than or equal to, or they can be equal to. If less than or equal to is given, then first you will change its sign to make it greater than or equal to. So, in the constraint sign, if it is greater than or equal to, and in the non-negative sign, obviously in non-negative you will again get greater than or equal to. So, when we reach the dual in the max problem, this is the dual. If you think from this side, when we go to the dual in max, here it is min, so there it will become max. So, what is the standard sign for max? The standard sign for max is less than or equal to, so by taking the opposite of greater than or equal to, here it will become less than or equal to. If it is written as unrestricted here, then it will become equal to. Opposite means either less than or equal to will come, or because it is unrestricted, equal to will come. And here, greater than or equal to, so in non-negative, it remains greater than or equal to. If by chance an equal to sign is given here, then you will have to put unrestricted. The opposite of the equal to sign is unrestricted. The opposite of unrestricted is equal to. It is the same in both cases. Equal to and unrestricted, unrestricted and equal to. But if you fix this basic outline in your mind that the standard sign for a maximization problem is less than or equal to, and for a minimization problem, the standard sign is greater than or equal to, then you will be able to solve the sum accordingly. Now, once we do this and see, it will become clear to you. For example, in this question, min z is given. If it is min z, then which one is the original problem? Min means the original problem is called the primal, so it will be of this type. Let me show you by doing it in this way. Follow this. This golden mantra has been given to you. Right now, it might seem a bit confusing, but it will be solved. Then you'll feel, wow, it's so easy. So, min z is given to you. The sign in the constraints is a little bit greater than. Greater than, 3 greater than. There are 4 constraints and all 4 are greater than. We can see that here as well. In a way, we've written it in short here too. Okay, and there are 2 non-negative ones, so now follow this. See, it's a minimization problem, so we are writing the dual. In the dual, how will we write it? We'll convert the minimization to maximization. Max equals 2. Now, in the dual, how many variables will there be? You need to pay attention to this. So, as I explained here, the constraints become variables. How much construction is there here? In the minimization, we can see 4 constraints. It's visible in the table. There is no need for tabulation here. But still, you can check from the table. If there are 4 constraints, then there will be 4 variables. Which means I have created 4 variables as y1, y2, y3, y4. Since the x series is running there, here we have taken the y series, so what will be max d equal to? 12y1 plus 20y2 plus 18y3 plus 40y4 subject to constraints. What will come in the constraints? Tell me. What will come in the number 1 subject to constraint? Number 1, what will be the first constraint? Now, the constraint that has to be made, you have to make it from the opposite angle from here. So, the value of this constraint, when you add all these, what should be the highest? It should be 6,000. This 6,000 here means that at least 6,000 should come. That's the concept. So now, how should you think here? See, if we first write down the question properly, then it becomes a bit easier to understand. Minimize d equals 6000x1 plus 4000x to subject to whatever is given in the question. We would like to write that down once. 4x1 plus x2 is greater than equal to 12. What else is there? 9x1 plus x2 is greater than or equal to 20. 7x1 plus 3x2 is greater than or equal to 18. 10x1 plus 40x2 is greater than or equal to 40. Alright, what else is there? What else is there? There is a non-negativity assumption given here, x1 greater than or equal to 0, x2 greater than or equal to 0. Just you follow this diagram which I have created on the right side with a red pen. So we are doing the dual here, so if it is min here, then it will become max there. How many variables will there be? There will be as many variables as there are constraints. Like here there are 4 constraints, so there will be 4 variables. For that, I have written y1, y2, y3 and y4. How will the objective function be formed? The availability in the constraint multiplied by y1 will make the objective. So, I have written 12y1 and 20y2. Now, see, these 4, otherwise, with these 4 itself, we are already earning 6,000, or rather, we are incurring a cost of 6,000 from x1. I said earning, but actually, it means we are incurring a cost. So, what will happen in the first one? 4y1 plus 9y2 plus 7y3 plus 10y4. Leave the sign for now. Let's write 6,000 ones. Leave the sign. In max problems, dual sign is always less than or equal to. Don't overthink. But still, leave the sign for now. What will you do in the second one? 1y1, Since the coefficient of x2 is nothing, it's 1. So 1y1 plus, the coefficient of x2 is nothing, so it's 1. 1y2 plus 3y3 plus 40y4. This is 4000. Third is a non-negative assumption. In this case, what will be the sign of y1, y2, y3 and y4? So, a simple rule says, from max to d, the sign will be less than or equal to, that's it. Otherwise, to tally this, you will have to roughly make this pattern in your sums. Only then will you be able to understand what is happening. The constraint whose sign is here, its opposite sign will come here. So, look, there were two signs here. What was it? Greater than? So its opposite, when flipped, will become less than. So, in the max sense, the sign of the constraint is always less than. If for any reason, the sign of x2 was written as unrestricted here. If it was written as unrestricted, then because of x2 we would have put equal to here. How does unrestricted equal to go, and how does equal to unrestricted go? If it was written as unrestricted, then fine, tell me what would happen in y1, y2, y3, y4. See here it is greater than, so here it will be the same. If it is equal to here, then unrestricted, but here it is greater than, not equal to, so it will be the same, and this is basic. What does the non-negative assumption mean? Everything is at least 0. There's one exception. If it equals, then it's unrestricted. Unrestricted means equal. It's absolutely simple. Just remember the standard sign for max, remember the standard sign for mean, then it will be clear. But also remember, if it is equal to, then it is unrestricted. Unrestricted means equal to. Remember this as well. It will be done. Alright, see, in this question you are getting the equal to sign. So let's do this one. First, let's write the question in the normal way once. Max equals 5 times 1 plus 10 times 2, subject to 2 times 1 minus 3 times 2 less than or equal to 7, x1 plus 2 times 2 equal to 4, and x1 x2 greater than or equal to 0. Alright, so it's better to write it like this as well. It's better to mention the non-negative assumption while writing. Now, the first condition is that whatever sum you are forming, if it's a maximization sum, then all should be less than or equal to. If you are given greater than or equal to, that is, the opposite one, then you will have to change its sign and first make it normal. So, in that case, it is not applicable. Now, we have to write its dual, so in the dual, I will change max z to min z, and then here, in front of the variables, I will introduce two new variables, which I will put in front of the constraints, that is, u1 and u2. So, what will min z be equal to? It will become 7y1 plus 4y2 subject to. You should know that this money can be earned from here, so to buy 1 plus by 2. And here I have written 5 and once again minus 3y1 plus 2y2. Here I have written 10 and y1 and y2 will also be there. By stating the non-negative assumption, alright. By stating the assumption on y1 and y2. Now, what is the concept of the sign? It means the patent sign is greater than or equal to and a non-negative. According to the calculation, it should be greater than only. But if it is equal to, then it will be unrestricted. So you have to look at it from here, the opposite, alright. If you see here, if it is less than or equal here, it will be greater. If equal comes, if in front of y2 it is equal, it will be unrestricted. You will have to write unrestricted. Understood? It's done. Now you have to pay attention to this flow, that this is coming from here and that is coming from there. Now, where is it happening? Where is it the opposite? That can be thought about a bit using your mind. Until you try it yourself again and again, it won't happen. Alright, next again is dual. You can try this on your own. The complete and good solution provided by the institute here, what they are doing is, they are solving it into steps. For the equal to part, they break it into two parts. Alright, one's as less than or equal to, and one's as greater than or equal to. That's how they do it. Alright, so for the equal to part, they break it into less than or equal to and greater than or equal to, then solve it and ultimately reach the conclusion. They arrive at the same result that I have got. So, you can directly do it the way I have done. Now look at this question, see what needs to be done in this one. Here, the max set is given and the max sign should be less than. But here, the greater than sign is given. One unrestricted given. In max, skip the greater than sign. If there is a greater than sign, then first we have to change it to less than. So, we will have to rewrite the primal first. Maximize z equals 3 times 1 plus 5 times 2 plus 7 times 3. Subject 2. What will you say? For what all? The first one is x1 plus x2 plus 3 times 3 equals 10. What is the second one? If you change the sign, you have to put a minus sign on both sides. Minus 4 times 1 will become plus because of the minus sign. Plus x to minus 2x3 less than equal to minus 15. Number 3, non-negative assumption, x1 greater than or equal to 0. x2 greater than or equal to 0 and x3 is given as unrestricted. So see, what new thing did we learn? In the primal, you have to change the sign first, then the sum will start. This is the primal given, so in the primal for maximization, each one should be less than or equal to. If it is equal to, then there is no problem. Greater than will not work. In minimization, it should be greater than, less than will not work. Now, we have to define the variables for the dual. So, suppose this variable is y1, this one is also y1. When writing the dual, what will I write? Instead of max z, it will be min z, and what else will we write? 10y1 minus 15y2 minus, right? Then what will be the subject to? Now, go column wise one by one. What will it be? Here, x1 is empty, so x1 means 1. x2 means empty 1, so 1y1 that is 1. Then minus 4y to 4y to minus 4y2 and against this there is 3. Then look at the second one, 1y1 from here, 1 from here, so 1y1 that is 1 plus, x2 is empty, so plus y2. Against this there is 5, then 3, so 3y1. 3y when then what minus? To y2 against this, there is 7. 3y1 minus to y2 against this, there is 7. Alright, and then you have to tell the sign of y1, so it means buddy. It's common, right, that its standard sign is greater than or equal to, but if somewhere here it is equal to, sorry. If somewhere here it is unrestricted, you have to look from this side, from the opposite angle. Here, the standard sign is greater than or equal to, but if it is unrestricted, then it will be equal to. And here, the sign that is coming here will come as the opposite, because non-negative means it will only be greater than or equal to 0. But if there was an equal to here, then you would have to put unrestricted. Alright, if you want to learn this even better, we have a complete video on dual on YouTube. You can watch that. I have tried that you shouldn't have to watch the video and you should be able to understand from here itself. But still, you are free to watch any kind of video on YouTube. Alright, now this is another dual act. In this, the primal is being formed in this way, which I have already made. It has already been formulated. Now, since it says write the dual, try this dual on your own and first make its primal and min equals x. I am not reading it. You should try the whole thing by yourself. Pause the video and try it on your own first. This has been tabulated. Now, read the question. Try it yourself, pause the video. Try primal and dual yourself. You need to solve this. We will not solve it. We won't go into the simplex method. We'll just do the primal and dual. Try, fast, fast, fast. So how is the primal problem coming? Minimize z equals x plus y. Or let's put x and x to not x and y. Let's put x and x too. In the dual, y1 and y2 are used. X plus x and y, which variable in the dual? That is created artificially. Subject to 0.12 x1 plus 0.10 x2. The minimum should be at least this much. Greater than or equal to 600. 0.10 x1 plus 0.40 x2 should be greater than or equal to 1000. x1 and x2 should be greater than or equal to 0. This is the primal. And this will be the dual. How will the dual be formed? If it is mean, then it will become max. Here, we will introduce variables. If y1 and y2 come here, then max equals 600 y1 plus 1000 y2. Subject 2. We will proceed from here. Point 1 to by 1 plus 0.10 y2. Here, with x1 there is nothing. It means forest. Then what will happen? 0.10 y1 plus 0.40 y2. Is it 1 with x? Then we have to find the value of y1, y2. Now, in the dual, since it is x, the constraint sign is greater than or equal to. Where is this coming from? It comes from the opposite side. If it was unrestricted here, we would write equal to. y1 and y2 non-negative, constraint greater than or equal to 0. Why? It is coming from here. If it was equal to here, then we would have written unrestricted. Done. If we don't solve it using simplex, that's fine. In exams, characteristics and dual problems are often asked as theory questions, so make sure to read this. It's time for MCQs. Practice them on your own. Don't ask me. MCQ practice is for self-study and you must do it. First, try to solve as much as you can on your own without looking at the answers. Whatever you can't do, just circle those questions, and when you revise them again and again, you'll be able to catch up on those. Alright, so that's it. I hope you enjoyed it. If you enjoyed the dual topic and want to know about it in detail, then do watch the video. There will also be dual problems in some MTPs and past papers, so make sure to attempt those as well. Before proceeding ahead, go through the past papers and MTPs once. Wherever you find dual problems, just check those. You don't have to go through the entire paper or all the MTPs. So, for you, there is a special resource, the SCM's Divya Jari Booty book, that Divya Jari Booty book. Just like these notes have been shared with you. Wherever the class notes are, this has also been shared there. You can refer to it. Whatever questions you see in linear programming in that, make sure to do them. It also includes dual problems as well. You won't have to search. Divya Herb, They call it a selective herb, saying that you don't need to search. You can just go to the chapter, find the sums, and do all the sums given over there. Because we have taken all the MTPs, all the past papers, and segregated all their sums chapter-wise and included them in this book. Alright, now if we look further, there are some more questions ahead as well. Those good ones, I show you those as well. Like, look at this question. This is a good question and one of the most favorite questions of the exam. Questions of this type have come up quite a few times before, so we just need to do its formulation. You should try it on your own once. If you just look at it without trying, it won't be of much benefit. Pause the video once and try doing the tabulation yourself to see what you get. Then watch my solution, you'll enjoy it. So here it is saying that the investor is well aware of the fact that maximizing total return is best possible if the help of linear programming is taken for that. He has employed you and provided you with the following information. So for that, he is telling us. He is mentioning various activities. A one-is-one activity, which is to invest in fixed deposit (FD). If you develop the habit of writing like this, you'll understand the question quickly. A 2 is government bonds. A 3 is mid-cap mutual funds. And a 4 is invest in equity-linked mutual funds. Invest in equity-linked mutual funds, equity-linked mutual funds. Alright, so there are 4 ways to invest. The total amount he has is 5 lakh rupees. So what is the total amount combined in all 4? He has 5 lakh rupees. To avoid excessive investment, not more than 50% of the total should be invested in government bonds and mid-cap mutual funds. Government bonds means a 2 and mid-cap mutual funds means a 3, so a 2 and a 3. Combined, it cannot be more than 50%. Not more than means less than 50% of the total. Total means a 1 plus a 2 plus a 3 plus a 4. Then, investing in bank FDs is very conservative, whereas investing in equity is very speculative. To avoid excessive speculation, at least 1 rupee must be invested in fixed deposits for every 3 rupees invested in equity-linked mutual funds. What does this mean? That at least 1 rupee must be invested in fixed deposits for every 3 rupees invested in equity mutual funds. So if 3 rupee goes into equity, then 1 rupee should go into HD. So if equity means a 4, then if 1 rupee goes into a 4. If 3 rupee goes into a 4, then 1 rupee should come into equity. Right?
This is what is happening. So now we need to understand which equation fits here.
Is a 4 equal to 3a1 or is 3a4 equal to a 1? Just think about it. If you substitute the values, you'll understand that if we are putting 3 rupees into equity, meaning equity means a 4, so if we are putting 3 rupees into equity. Alright, so what should be the answer for a 1? It should be 1 rupee. 3 and 3 cancel out, so you get 1. This is coming from the second one, and in the first one, if we are putting 3 rupees into equity, so if we put 3 in this, the answer for 1 is coming out to be 9, so that's incorrect. Alright, the one below is correct. Then you are given the data for ROI of 4 activities. You have to maximize the total return and arrange them accordingly. To formulate and solve, what does our rule say first? You should tabulate it. Alright, so let's tabulate it. See how this sum will be tabulated. There is no fixed rule for tabulation. You are doing the tabulation for your own understanding. You can do it in any order. Normally, the products which are made variables are the ones we put here. Normally, the habit is this, Then their ROI is given to us at different percentages: 5.5%, 7% and 10%. Apart from that, nothing else has been told to us about this. Just this much is definitely mentioned, that the total amount of money we have altogether is how much. If it is 5 lakh rupees, then the question is to maximize the total return, and where to invest has been specified to you. So, you can assume that wherever you are investing as x1, x2, x3, x4x, like this. And if you have got these variables, then you can go ahead and formulate it. So, 3 steps are done, right? Tabulation is done. In tabulation, we got these details and there was nothing else worth writing. Don't write anything unnecessarily. Then, the objective became clear. Maximizing return means one variable per return type, so with 4 types, there are 4 variables. Once identified, the process ends. Now I'll start writing. I'll write the formulation. I'll write it in the objective function. Maximize equals 2.04x 1.055 x2% because 04x1 05 x2 07 x 3.10 x4 and subject to constraint we will write. Subject to constraints, what will be the constraints? The first constraint will be that altogether how much money do we have? 5 lakhs. So, less than or equal to 5 lakhs. What is the second constraint? It was mentioned a 2, a 3, a 2, a 3. See, government bonds are a 2 and a 3 is mid-cap. So together, not more than 50% should be invested in these two. So, a 2 and a 3 means x2 and x3 should not be more than 50% off. The rest, 50% of x1 plus x2 plus x3 plus x4. This is how it will go now. Look at the third one. The third one, which is actually the second one, is correct. And here you can see the word at least is written. At least rupees 1 should be invested. So, I had explained it with equal to. But it says at least. Alright, should be invested in FD for every 3 rupees invested in equity-linked mutual funds. So what does at least mean? That your FD amount can be more, right? Okay, so the FD investment is 3A1. If the FD investment is 3A1, then instead of 3A1, we will write 3 times 1. We must write greater than or equal to x4, not just equal to, as I explained before. Because it says at least, and which one is at least? At least means this amount will be the minimum. It can be more than this. If it can be more, then we put greater than or equal to. After that, it can be more than x4, but 3 times x4 does not mean 3 times x1. It does not mean that 3 times x4 is equal to x1. Don't think like that. It means that for every 3 rupees you put in equity, you have to put at least 1 rupee here. Got it? So, this requires a bit of deep understanding here as to why greater than or equal to has been used. For example, do you think 3A4 equals a 1 sounds correct? In the same way, here greater than or equal to doesn't seem right. Yes, but less than or equal to seems correct. At least makes you feel that having less will do, but that's not the case. It's okay if the FD amount is more. Think of it this way, since at least is mentioned for FD, the FD amount can be greater than the condition that you are giving. At least means it should be greater than or equal to. We all know that at least means it should be greater than or equal to, so you can remember it this way as well. And the FD amount can also be higher. That's why here, for 3x we have put greater than or equal to. What is the fourth point saying? What is the fourth condition saying? That's it, there are no other conditions. After that, the non-negative assumption will come in. The non-negative assumption is that x, x2, x3, x4 are all greater than or equal to 0. Is it done? It was a really good question, wasn't it? That mistake always happens in it. You have to keep this in mind, that mistake always happens. look at the next question. What is this question saying as well? Question number 2. Okay, you want to see the answer of question 1? See the answer. The answer for question 1 is given here. Here, we have just moved x4 to this side. Alright. We moved this to the other side as well. There is no need to solve everything. We just leave it like this. If you bring all of these to this side, then brother, let's move to the next question, number 2. It's easy, or you can also try it yourself. What's new in this one? The selling price is given. All the costs are given, material, wages, and then wages again. There is variable overhead in 3 departments. Subtracting these gives the contribution per unit for A. Hours required for departments 1, 2, and 3 are given. Then, given that the maximum number of employees in department 1, 2, and 3 are 20, 15, and 18 respectively, and the maximum available hours per employee in each department is 40. So, we have to take the total hours because hours are given, so we need to consider the total hours. If there are 20 employees, then 20 times 40 hours. If there are 15 employees, then 15 times 40 hours. If there are 18 employees, then 18 times 40 hours. That's how it will be calculated. This is 800, this is 600, and this is 720. So by calculating contribution per unit, you get this value, and once you have the total hours, you can easily formulate it. You have been asked to formulate. There will be 2 variables, x and y, or x1 and x2. You can write it however you like, and it has become very simple. You just need to calculate the contribution and form an equation by maximizing the contribution. There will be 3 constraints in the subject to part, which will be of the less than or equal to type, and don't forget to include the non-negative assumption. Now look at illustration number 3 here. You can easily do number 3 as well. In this, it is asked to solve. But we will not solve it. We will only do the formulation. So, the company buying scrap metal has 2 types of scrap available to them. So, let's start arranging the data. Scrap 1 has 20% of metal A. Metal A, as given, is 20%. Then it says 10% impurity. Impurity is mentioned as 10% and 20% metal B. So, metal B is 20%. Then the second type is scrap 2. The second type of scrap has 30% material A, 10% impurity, and 15% of material B, that is metal B. The company requests at least 120 kilograms of material A, so at least means greater than or equal to, and at most 40 kilograms of impurity, so less than or equal to 40, and at least 90 kilograms of metal B, that is greater than or equal to 90 kilograms. Alright, if it says at least, then it's greater than. If it says at most, then it's less than. The price for the 2 scraps is 200 and 300. So, their prices are 200 and 300. To determine the optimum quantity of the 2 scraps to be purchased by the company, so that the requirement of the 2 metals and the restriction on impurities are satisfied at minimum cost. The objective is minimum cost. The tabulation is done, that's step 1. The objective is minimum cost. So, this price means cost, and for the cost that is given, variables will be assigned. So, let's say the variables are x1 and x2, and you can easily formulate it. Alright, once the variables are set, the formulation becomes easy. What will you do in the formulation? Minimize. This is a minimization problem. Alright. Minimize z equals 200 times 1 plus 300 times 2, subject to x1 times 0.2 plus x2 times 0.3 is greater than or equal to 1. 20 times 1 times 0.1 plus x2 times 0.1 is less than or equal to 40. x1 times 0.2 plus x2 times 0.15 is greater than or equal to 19. x1 x2 greater than or equal to 0. Is it done? Look at the next question. It says, an engineering company dealing with combustion equipment and furnaces is planning an advertising strategy. they have two monthly industrial magazines under consideration. The first magazine has a reach of 2,000 potential customers per advertisement, and the second has a potential of 3,000 customers per advertisement. So, we have two magazines. Let's do the tabulation. Alright. Suppose here we do the tabulation for both Magazine 1 and Magazine 2. How many customers are there? Potential customers are 2,000 and 3,000. Then it says the cost per advertisement in the two magazines is 6,000 and 9,000. The total budget mentioned is 1 lakh. There is an important requirement regarding the total reach of the business. The group having an annual turnover below 20 crores must not exceed what is written here, 3,000 potential customers. The reach of the two magazines for such business group customers is respectively 300 and 150 potential customers per advertisement. So, a condition has been put regarding a customer group. So, I have written customer group. Alright. The customer group whose turnover is less than 20 crore, that is one classification of customer. Their number should not exceed 3,000. So, the total should be 3,000. And what is the reach of the magazine? Here it is 300 and here it is 150 per advertisement. Okay. How many times should the company advertise in the two magazines to maximize the total reach? The objective given is to maximize the total reach. So, the tabulation is done, the objective is set, which is to maximize the total reach, and total reach means the potential customers. Which is the reach? What does total reach mean? Total reach means potential customers, and these are your two constraints, customer group and cost. So what is your objective function? Maximize Z equals, here add X, here add Y. So 2000X plus 3000Y. What will be the subject to? 6000X plus 9000Y is less than or equal to 1 lakh. And what about the customer group? 300X plus 150Y is less than or equal to 3000. Then what will happen? X, Y greater than or equal to 0. Done. We are only formulating right now. Here, number 3, which number is it? 4. The complete final solution for number 4 is given, but we are not going to the final solution. We are only learning up to the formulation. Okay, in the 5th question, it says set the data in the simplex table, so we are ignoring this since it's about simplex. We haven't learnt about the simplex table yet, we are skipping this chapter for now. But you should try the dual on your own. Are you able to make the dual or not? Isn't it? Pause the video once and try it yourself. If the primal is given as minimization, then all its signs should be less than. So, since this is given as greater than, we will change it first. Minus 2 times 1 plus 4 times 2 will become less than or equal to minus 12. Alright, this sign change is very important. What are we doing in minimization? In minimization, all the signs should be greater than. So, we have to change its sign. We have to change its sign, minus 3 times 1 plus x to minus 2 times to greater than or equal to minus 7. How is the sign changed? On both sides, you have to multiply by minus, reverse everything. Change plus to minus, minus to plus, plus to minus, and with 7 also, minus 7, and change the sign as well. Changing the sign means you have to reverse the sign on both sides. Since it's a minimization problem, the standard sign for minimization is greater than, so it should be greater than. Less than won't work. With less than, we cannot form the dual. Greater than or equal to will work. Unrestricted will also work. So now how will we make it? Try it out. If you try it yourself, you will learn. But if you try, then how will you write the dual? Here, we introduce a new variable along with the constraints. Suppose the variables are y1, y2, y3. So what will we write? If it is min z, then we will write max z. Maximize z equals, and we will write it by multiplying with the constraints. Minus 7y1 plus 12y2 plus 10y3 subject to. Subject to, then from here, you have to go column wise like this. So how will it come? Subject to 3y1 plus 2y2 minus 4y3. Can you see this 3, 2, minus 4? Then on that side, with x1 it is 1. Then from here, and minus 1y1 it won't be minus. This has been reversed. It will be minus 3, you have to see from here. Saw it from there. Checked it from the column. Made a mistake. I should have checked from here. I had to take the minus 3, 1 from the new equation. Minus 3, then plus 2, then minus 4. Then for the second one, it's plus x2, right? So it's plus x2 and with it there's 1, and with x2 there's nothing else, so it's 1, so in its place y1 will come. Then what will come next? Minus 4 by 2. What comes next? Plus 3 by 3. Here we will get minus 3. Then what will come in the third one? Minus 2. Then here there is no x3 at all, so nothing came for y2 here. Minus 2 y1 came, then nothing came for y2, then for y3 it will be 8y3 plus 8y3, and against that, what is there above? It is minus 2. Now, since it's a maximization problem, what is the standard sign? It is less than or equal to. Alright, where is this less than or equal to coming from? It is coming as the opposite from here. It is coming as the opposite from here. But one thing is given as unrestricted. If it is given as unrestricted, then what we will do is, for the third one, we will put it as equal to, and then for y1, y2, y3, whatever sign is needed, if it is greater than there, then here also it will be greater than. If it is greater than, then it will be greater than here as well. If the sign is this particular one and it is equal to, then it will be unrestricted. This is the solution. Right now, without practice, it doesn't quite settle in. But you must have understood quite a lot by now. If you manage to crack it, then you have understood it. Opposite comes, meaning you have to write its sign by looking at the opposite. Now, it's not necessary that it will always be opposite. It's just common sense that for maximizing z, the sign should be less than. So here, if its opposite is a, then it will come as same. If this is opposite a, then this will also come as same. If it is same a, then equal to should be for unrestricted, so it should be unrestricted equal to. Here, as it should be unrestricted, we put equal to. So you can do this sum as well. This is also a dual question. Here, you have to do both primal and dual first. First, it is saying that you should solve the whole thing. But we are not going to solve it. We are only doing the primal and dual. So we will proceed according to the primal. So you see, it is a very easy question. It is telling how much raw material A and B is needed for product X. So you will have to make a tabulation. There are 3 products, X, Y and Z. You can see which raw materials are being used in them. A, B, C are here, 1 unit here, 2 units here, 2 units here, 2 here, 1 here, 5 here, 1 here, 4 here and 1 here. Then comes the profit. It is 40, 25 and 50. Alright. And haven't they put any condition here? It is only mentioning 8 units of product X required. See what is not given here. They haven't mentioned how much total of the constraint is available. So it seems like there is a printing error here. You'll understand after looking at the solution. In the solution, see, the dual solution is given here. So in the dual, the constraint becomes the objective and the objective becomes the constraint. So you all got 40, 25 and 50. And the quantity that should be here is clear after looking at the solution. 36, 60 and 45, 36, 60 and 45. So this is your capacity, or you can call it total available, which should have been given in the question. It must be given in the question, it must have been provided. We figured that out by looking at the solution. So now, from this you can make the primal, and it's a very easy question. You can also make its dual. There's no issue in this. You do it on your own. The solution is given here. You can make it. The solution for the dual is given but not for the primal. So the solution given, we haven't learned that yet. Nor have we learned the graph method or the simplex method. But we are doing the formulation part. Alright. So now it's clear to you how to do everything. Very good. Alright, thank you so much for being with me till here, and you can also thank me for making you do so much extra. It is not my duty to do all this. Giving so much hand-holding was not my responsibility. My duty is to teach you the concept and then let you do it on your own. Still, by God's grace, I managed to get this done for you. Alright. Okay, now we are going to start the transportation chapter. Come on, join in. In transportation, the first question is, how does the northwest corner rule work? Alright. A flow chart of transportation was shown to you in class. Let me remind you again, what is the first thing we do? We check whether the problem is balanced or not. The problem should be balanced first. If it is not, then add a dummy to balance it. After that, we find the initial solution. Alright, after the initial solution, what do we do next? We perform the optimality test to see whether it is final or not. If it is satisfied, then stop and give the final conclusion. If it is not, then what should be done? You have to find the revised allocation using the loop matrix. So, the revised allocation has to be found using the loop matrix. The revised allocation will again undergo the optimality test. If it passes the optimality test, then stop. Otherwise, the loop and revised allocation process will continue again. This is its flow. While checking the optimality test, you have to apply a check called the degeneracy check. You have to ensure that the problem does not become degenerate. Alright, if degeneracy occurs, then in the least cost unallocated independent cell, a new allocation will be added, which is introduced as E. E means epsilon. Epsilon means epsilon. Epsilon means nothing but zero. It is something very close to zero. What are the methods available for the initial solution? Northwest corner rule, least cost allocation method, and one Vogel's approximation method. It is written as Vogel but pronounced as Vogel. So left. These three methods are available, and if nothing is specified, the third one is the best. But in the exam, questions are also asked using these two methods where you are told to find the initial solution. You are not asked to do the optimality test for them. The optimality test is only asked with VAM. The transportation algorithm, which is purely a minimization algorithm, handles the minimization objective in this. In this entire process, if it is a maximization problem, then first we convert it into an opportunity loss matrix and then we minimize the opportunity loss matrix. The solution for minimum opportunity loss is the solution that we need for the maximum objective given in the question. So, I have told you the entire gist. Now, based on this, we have to move forward. We have to proceed further according to this. So the first question here is about the northwest corner rule. The matrix for the northwest corner rule is already given in the question, showing that from this plant there are 3 or 4 retail shops. Their supplies are given and their demands are also provided. Alright, so we have 3 plants. We have 4 shops where transportation needs to be done. The costs are given inside the matrix. First of all, we should check whether it is balanced or not. How do we check if it is balanced or not? We will check the total supply. It is coming to 150, and then we will check the total requirement. 40, 50, 90 and 60, the total is coming to 150, so it matches from both sides, meaning it is balanced. If it is not balanced, then we will have to add a dummy to balance it. In the dummy, you can add a plant or you can add a retail shop as per the situation, and when you sum using the northwest corner rule, the cost has no relevance. It doesn't matter at all. Just ignore it. So, what does the northwest corner rule say? Suppose, in this question itself, I show you how to go to the northwest corner cell. Which is the starting point? This is the starting point. This is north, which is up. West is completely to the left. And corner means go to row 1, column 1 and start from there. Now, see how much you can allocate there. Check how much can be allocated. It will be the lower of demand and supply, so the answer is 20, so 20 has been allocated. Forget about the cost. Cost doesn't matter here. As you allocate, you have to deduct it here and make it 0. If you subtract 50, it will become 30. Alright, you can write the cost if you want, but it has no relevance here. Meaning, when you solve the solution in your notebook, the first thing you should check is whether it is balanced or not. Check for a balanced problem. This is the first check. In the current case, total supply and total demand are matching, so you can say that this is a balanced problem. Alright, you can say it is a balanced problem, and secondly, to find the initial solution, you will create a matrix just like the one given in the question. You will have to make that matrix. You will make the matrix exactly as it is. And wherever I am allocating the quantity, you will write the quantity there. Whether you write the cost or not, it doesn't make a difference in the northwest corner method. It matters in other methods. Secondly, like here, if 0 comes below, wherever 0 comes, if 0 comes in the next column, then you have to move to the next column. If 0 comes in the row, then you have to move to the next row. That's the only rule. So if 0 comes in the column, then we will go to the next column. In the next column, here 20 and 30 are possible, so between 20 and 30, 20 will be allocated, so the minimum one will be allocated. After this cut, it becomes 0 for the 30 cut. So if the column is finished, we will move to the next column. Then next, out of 10 and 50 here, 10 will be taken. Then after cutting 10, it becomes 0. After cutting 50, 40 is left. If 0 comes on the right side, it will go downwards. Below, 40 and 75. Since it's 40, 40 will be taken. After cutting 40, it becomes 0. After cutting 75, 35 is left. If it becomes 0 below, then we will move to the right. When we come here, according to 35 and 60, 35 will be taken. After cutting 35, it becomes 0. Then 60 cuts will come to 25. How much is left? Is 25 left? If 35 is gone, at the end 25 and 25 are left, so the last one gets allocated automatically. After cutting everything, it should be 0. Check if everything is 0. Now in the solution given by the institute, a new matrix is made at every step, which isn't possible in the exam. So you can match the final answer. 20, 20, 10, 40, 35, 25, 20, 20, 10, 40, 35, 25. And if you are asked to find the total cost from this, then by multiplying 20 by 3, 20 by 5, 10 by 7, 14 by 2, 35 by 2, 25 by 2 and adding them up, you can get the total cost. But there is no guarantee that the total cost calculated in this way will be the minimum. We haven't even done the optimality test yet. Now, if you do the optimality test using the northwest corner rule, it becomes quite a lengthy process. VAM is a method through which the optimality test is passed quickly. So you have understood this now. In the northwest corner rule, the way to solve this sum is that in the exam, first you will check the first step, then you will find the initial solution. Now, the second question given here is asking you to solve the same example using the least cost method, so the process remains the same. There are two steps in the process. In step 1, you have to first check whether it is balanced or not. Don't forget that in this, the balance is not skipped. It's not like that. In step number 2, then we have to find the initial solution. But as the name least cost method suggests, here we will consider the cost. So for that, what we do is, once we take the data given in the question. Suppose we have created this question. For example, in the initial solution, this matrix will be made. So, after making such a matrix, what does the least cost method say about how it works? First of all, you have to look at all the costs given and among them, select the least cost. If you see the least cost is 2 and 2 appears once, twice and 3 times, so you have to search for the least cost. What is step number 1 in this? Search for the least cost, and if there is a tie in the least cost, meaning if there are multiple least costs, then we say to put a dot there. By putting a dot, you will remember that there is a tie. Now, see how much can be allocated in each of them, and among those, select the one with the highest value. For example, here 2 is the least cost, so you can see 20 and 75 here. From 20 and 75, we know that 20 will be allocated, the lesser one will go. Then, for this 2, you have 60 and 75, so 60 will be allocated. Then, for this 2, between 60 and 25, 25 will be allocated. So, when there is a tie, the one where the highest quantity can be allocated will be selected. Only the one where the highest quantity can be allocated will be selected. If there is a tie, only the one with the highest quantity will be selected. Accordingly, this one has been selected. The other 2 have been removed, so you can do this mental calculation or use a pencil and erase them. Now, this 60 has come home. Now, as soon as 60 comes here, the calculation will be done. After deducting 60, it becomes 0, and after deducting 75, it becomes 15. Alright, now we won't make the matrix again. What we do is, with a pencil, we strike off wherever it has become 0, so that it doesn't disturb us anymore. We can continue working in this same matrix. Alright, so select the least cost. If there is a tie, take the highest quantity. Then adjust the row and column accordingly. Cancel out supply and demand to make it 0. Now you just have to repeat these steps again and again. Keep doing this until everything is completed, and each time check which one has the least cost. Right now, the least cost, out of all, the least cost, so how much will go there? 20, and it gets cut by 15. That's why it's important to cut, so that you can see the new quantity. Between 15 and 20, which one will go? If the lower one, 15, goes, then what happens when 15 is cut from 15? What will happen to 0 and 20 cuts? 5. Alright, after cutting 15, it becomes 0. 0, 20 got cut. 5. So wherever you get 0, you will strike that off. And then repeat the same steps again. What is the least cost showing? 3, 3 and 3. It's showing in 2 places, so it's a tie. Since it's a tie, 5 will go in the upper 3 and 5 will also go in the lower 3. So, if you don't get the highest quantity in a tie, then if the quantity is the same, what will you do? So you can take anyone. If the quantity is the same, you have to select any one, and there are 5 in the upper one as well. There are 5 in the lower one too. So, suppose I selected the upper one, then this 5 gets cut and becomes 0. 50 gets reduced to 45. So now, where we got 0, that came in row 1. In row 1, so row 1 also gets cut and is finished. Alright, now among the 4 values left, which one has the least cost? It's 5, So what can go on this page? Between 45 and 20, the lower, 20 can go. 20 is cut to 0, 25 is reduced. 45 cut will come to 25, 45 cut will come to 25, so this also is over. Now, the two values left are 25 and 25, so this 25, that 25, both get cut to 0, this also becomes 0, that also becomes 0. Finished. Elimination is done. Now, if you are asked for the total cost from this, you can calculate it. Always do this cutting and crossing out with a pencil, never with a pen. It is very important to carry a pencil in the exam hall, so 5 number 3, 15 number 5, you can calculate all these costs. 3 number 3, 5 number 5, to number to 15 plus what is there in the third one. 5 number 3 to 20, the cost is written outside. 7 number 3 to 25. Then 9 number 3 to 25. Then to number 3 to 2016. Understood? So from this, the total cost will also come out. 5, 20, 25, 15, 60 and 25, 5, 20, 25. See, in this, the one that was chosen, the lower one was selected. 5, 20, 25, 15, 60, so because the lower one was chosen, the answer changed a little bit. Alright, the answer changed a little bit. By choosing the lower one, the answer changed a bit. Here it is written that both P1 are 1 and P3 are 1 have the same value, and we arbitrarily choose either P3 are 1 or any one as per our wish. So in this, the lower one was chosen, and that's how this answer came. Did you understand how the total cost can be calculated? It came out to 665, right? Now comes the third one, VAM. Now, the same sum has to be done using VAM. So what will I do? Now, I won't do the entire sum for you. Of course, you must have understood this by now. But now, what I can do is pick up any one question and solve it completely for you, so that you can understand how the entire process works. Now, we won't take the first question. It's better to take a question which involves more calculation and is a complete sum. That will do, right? Like in illustration 4, it says to show the same sum by doing the optimality test. Alright, that can be done. Illustration 4 can also be done. But we'll take something a bit more complex. Then, to solve an unbalanced problem, you will have to add a dummy warehouse or a dummy factory. You will have to add a dummy warehouse or a dummy factory. Alright, and its cost per unit should be taken as 0, and the availability or requirement should be set according to the deficit that is coming up. Alright, so first of all, do this, make it balanced. First, balance it and then we start solving. For example, this sum is unbalanced.
How do we know that? I have written it in one place, that's how we know. Otherwise, if you add up the capacities, it comes to 800, and if you add up the demands, 5, 3, 8, 3, it comes to 1100. So, 800 and 1100 are not matching, so where is the shortage happening?
The demand is higher, the capacity is less, so we will add a dummy plant whose cost will be 0, 0, 0, and here it will be 300 whose cost will also be 0, 0, 0, and here it will be 300. The answer is here. Okay. Next, maximization problem. Maximization problem. How do we handle a maximization problem? I said that our entire algorithm is designed for minimization. It has been designed to handle minimization. If you want to maximize, then you will have to create an opportunity loss matrix. How is the opportunity loss matrix made? The highest value of profit given in the entire matrix in the question. Here, by subtracting the given profit from the best profit or sales, whichever is applicable, you calculate the opportunity loss for all the cells and then you minimize that. So, what is the specialty in all this? For example, if you see here, the question says the cost of production of plants is 15, 16, 17. The selling price has been given as 44 and 4700, which is at the customer's end, and here the cost of transportation matrix has also been provided. The problem says that you have to formulate it as an LP model and find the optimum solution using transportation. And what exactly do we want to do here? Since the selling price and cost of production are also given, we will focus on profit. Whether it is written in the question or not, since the sales data is given, it will be about profit. Since sales data is given, you have to go for profit maximization. So for profit maximization, first I will have to make a profit matrix. Alright, how will the profit matrix be made? You will have to calculate the profit for each cell. How will it come out? Look, the selling price for customer A is known. If you see here, for A it is 4400 and for B it is 4700 and the plant-wise cost of production is known, M1 has 1500 here, 1600 here and 1700 here. So, this is also the transportation cost. So, how will the profit be calculated here? Profit is equal to selling price minus cost of production minus transportation cost. So, by making a fresh matrix, we can figure this out. Alright, if you look at the working here once, you will understand. 4400 selling price is the cost of production of this sale. Take the cost from here, 1500, and transportation will be 1000 rupees. So, 2500 is gone, and if we subtract 2500 from 4400, we get 1900. So, this is the profit, which I am writing in black. Then, 4400 minus 1600 and 2000, that is, 3600 is subtracted, so 800 is coming. If you do 4400 minus 1600 and 2000, you get 800. Then, if you do 4400 minus 1700 and 1500, you get 1200. Then, what am I saying about 4700 minus 1500 and 1900? If you do 4700 minus 1500 minus 1500, you get 1700. Then, if you do 4700 minus 1600 minus 3000, you get 100. Then, if you do 4700 minus 1700 minus 2500, you get 500. So, this is the profit per unit. Profit per unit, profit per unit. So, this working of profit has also been done here. 1900, 800, 1200, 1700, 100, 500, and now look, here's one more thing. See, in the question, capacity. This time, demand has been given on this side. So, normally, what do we see? Capacity is on this side, demand is on that side. Alright, but if you want, you can also solve the sum by reversing it, or you can do it this way as well. It doesn't make any difference. No matter how you do the sum, it will be correct. Now, you were asked to formulate this. I had explained the formulation of transportation in the LP chapter. So, while doing the formulation, we should know the objective. We know that it is profit maximization, and once we have all the profits, we can define our variables. But as I had mentioned, in the transportation problem, we should check first whether the problem is balanced or not. So even while formulating, we need to check once whether it is balanced or not. Then, when we define the variables, we need to check again whether it is balanced or not. You will see that the demand here is coming to 7100 and here is the capacity. 3, 2, 5, 4, 9, so it comes to 9000. So, it is not balanced either, our capacity is more. Our demand is less, so we will have to add a dummy customer. We will have to add a dummy customer whose profit we will assume to be 0. What is the profit? It is 0 and its demand? What will we say? We will tell our demand 1900, the balance that is coming, that demand is 1900. 70, 100 and 1900, right. So sir, what difference does it make if the profit is 0? It won't make any difference. It's just for formality so that the sum looks complete. That's all, nothing else. So this dummy act was a unique thing that by adding a dummy customer, now we will focus on the formulation. So what does the flow of formulation say? First of all, you should have the tabulation. That is already done. Now you should know the objective. You know that you have to maximize profit. Third, you should know the variables so you can define the variables here. x1, x2, x3, x4, x5, x6. The number of variables will be equal to the number of profits. Alright, now you can write your formulation. How will you write the formulation? Let me write it over here itself. What will the formulation be? Since we have to maximize profit, it will be maximize equals 1900 times 1, x to 800, 700 times 2. Then what is there? 0x3. Now, even if you don't write 0x3, it's fine. Plus 800 times 4, plus 100 times 5, plus 0x6 plus 1200 times 7, plus 500 times 8, plus 0x9. Alright. Subject to constraints. What will be the constraints? Subject to constraints. What will be the constraints? Number 1. Demand and capacity are constant. Remember, I said writing equal to also works in LP. You can also use less than or equal to and greater than or equal to. Demand means at least this much. Demand means greater than or equal to. Capacity means you won't get more than this, it's less than or equal to. Even writing equal to works. So suppose we are making a constraint regarding capacity. So what do we write? xx plus x2 plus x3 equals 2000, x4 plus x5 plus x equals to 3000. xx is not to be spoken to. You don't have to mention the variables of the new dummy that has come. Then x7 plus x9 equals 4000. After capacity, the second number is demand. What will come for demand? Do it from here. xx plus x4 plus x7 equals to 3500. The next two plus x5 plus x8 equals 3600. And the third one, x3 plus x6 plus x9 equals 1900. Then what will come in the third one? Non-negative assumption, which will be greater than or equal to 0. The value of I is from 1 to 9, greater than or equal to 0. The value of I is from 1 to 9. That's it, it's finished. But what new did we learn in this? Unbalanced formulation. Alright, if it's unbalanced, then how should we do the formulation? If you don't do this even once, you'll definitely make a mistake in the exam. You never consider this dummy one. You would have seen it directly in the exam. Now after this, it says to solve and show using transportation. So to solve this problem, if we use the transportation algorithm, then how will it be? For solving with the transportation algorithm, the profit matrix will not work. We will have to make an opportunity loss matrix. How is the opportunity loss matrix made? Highest profit minus the given profits. Which is the highest profit among all these? 1900 is visible. 1900 is the highest profit. We will subtract the given profit, and if you want to make it a bit clearer and easier, you can make a plant-wise table. What are the names of the plants here? M, M2 and M3. It's M1, M2, M3 and the customers are customer A, customer B and dummy. Okay, and then you know their capacity and you know the demand as well. If you want, you can extend this same sum and apply VAM right here, so you'll have to arrange the matrix accordingly. If you want to do VAM here, you must remember how to arrange the matrix for VAM. If you don't remember, I'll make you do a sum now. Let me show you which one I'll make you do. But I'm just creating a framework. I won't solve all of it. I'm giving you a structure. What will the opportunity loss matrix be? Look, let's do customer A and M1 first. So 1900 minus 1900 will be 0. Let's write it here in small. When we work on this same sum, we'll write it a bit smaller so that we can also mention the quantity here. Then, for the second one of M1, 1900 minus 700 gives 1200. Then, 1900 minus 0 gives 1900. Now, come to this side. 1900 minus 800 gives 1100 and 1900 minus 100 gives 1000. 1900 minus 0 gives 1900. Now come to this side. 1900 minus 1200 gives 700. 1900 minus 500 gives 1400 and 1900 minus 0 gives 1900. That's it. This is capacity and demand. You can write it down. What is the capacity? 2000, 3000, 4000. We used to write this in big letters. 2000, 3000, 4000 and what are the demands? 3500, 3600 and 1900. 3500, 3600 and 1900. And now, if we have to do the working, we write the penalties here and also write the penalties here. If we can make a little more space here, we can write the penalties as well. We might get a chance to solve it right here through practice. It's not necessary that you first show the opportunity loss matrix and then draw it again. Try to be a little smart, merge it together. Insert the initial solution into the opportunity loss matrix. Did you understand? I'm not doing this. I've made the matrix for you. I will make you do a sum in which all the steps will be covered. The rest you will have to learn on your own at home, brother. To make this even simpler, you can do one more thing. You can make a matrix in rupees in hundreds so that you have to write smaller values here. So this is also an allowed method, which makes the sum look a bit shorter and faster. Okay. We will do the problem. If we get a sum related to degeneracy, that would be great. Illustration 7 seems like a good sum that is worth doing. It will also have degeneracy. So how does degeneracy occur? Let's see. It will also capture the alternate solution in that. In 7 and 8, it's fine, and we will also see how to deal with prohibited routes. Where we are not allowed to transport or not allowed to locate, there we use it. The value of m is equal to 1. Infinity means it is equivalent to infinity. The value of m is equivalent to infinity. After this, there are quite a few more comprehensive problems with questions given here. Alright, so for maximization, I would like you to try making the profit matrix on your own and see. Just like I explained earlier, it will be made in the same way. You don't have to do the formulation as per ALP, just try making the profit matrix and see. Alright, then this is question number 2, which is about maximization. You will make its opportunity loss matrix. In the opportunity loss matrix, the highest value. You will see which is the highest value and then subtract that from all the others. Here, the opportunity loss matrix will be formed and then, suppose it is unbalanced, whenever it is unbalanced, you will add a dummy in the original problem. Whenever you add a dummy, you will add it in the original problem. Here also, it will be unbalanced. 500, 600, 750, 800, or the total is coming to 2650 from the column side, and from the bottom it is coming to 750, 600, 500, 800, 1000, so this is coming to 3650, so the dummy comes on this side. Here, the dummy value is 1000, so I will put 0 for the dummy at the profit level. When do we put 0 value? At the profit level, I will always put the dummy in the original sum. You will not put a dummy in opportunity loss. You will always put the dummy in the original, and now, by doing 1 minus all the values, you will create the opportunity loss matrix. Alright, so after making the opportunity loss matrix, do try solving this sum on your own. This sum is given here, so it can come in your exam. Some hints for it are given here in the question. Alright. Of the third question, you need to understand the formulation. If you understand its formulation, the sum will be done. Consider the problem of scheduling the weekly production of certain items for the next 4 weeks. Week 1, 2, 3, 4 have been written. The cost of production of the item is Rs 10 for the first 2 weeks, so 10 and 10 and 15 for the last 2 weeks, which has been written. Weekly demand, and here, let's say production has happened and now we are talking about demand. Weekly demand for week 1, 2, 3, 4. Let's assume here we will write production capacity and here we will write demand. So if we are writing demand here, then this 10, 10, 15, 15 will not come here. 10, 10, 15, 15 will then come here, and the demand that we have given. 300, 700, 900, 800 must be met. The plant can produce a maximum of 700 per week, so it's 700, 700, 700, 700. Then what is it saying? In addition, the company can employ overtime during second and third week. Overtime can be done in the second and third week. This increases the weekly production by an additional 200 units, so how much will the overtime be? Overtime can be done in week 2 and overtime can also be done in week 3. Alright, then week 4 comes and from that you will get 200 extra units. So here also 200 and here also 200, okay. Then what is it saying? The production cost increases by 5. If it happens in week 2, it will cost 15 rupees. With 5 rupees and 15 rupees, it will cost 20 rupees. Then it says excess production can be stored at a unit cost of rupees 3 per week, meaning if we produce in week 1 and send it in week 1, then this is the cost. If you produce in week 1 and sell it in the next week, then there is a storage cost of 3 rupees for 1 week, so the cost will increase here. Similarly, if you produce in week 1 and sell in week 3, then the cost will increase by 3 rupees each time. If you sell in week 4, then the cost will increase by 3 rupees each time. Similarly, in week 2, 10 will become 13 here, because for week 2, it won't be in week 1, right? For week 2, it will start from week 2 itself. Here, if it is 10, then it will become 13 and 16. The overtime for week 2 will also start from week 2. If it is 15, then here it will become 18 and 21, right? Week 1 will start from week 1 itself. Alright, week 2 will start from week 2 itself. For week 3, I won't write it here in week 3. If there is a sale from week 3 as well, then if it is 15, here it will be 18. If it is week 3 overtime, and if it is 20 here, then the same 20 will be here, and if it is 20 here, then here it will become 23. And for week 4, there will be dash, 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 and in week 4, it will be 15. First, check if the capacity is balanced. 7 and 7 is 14, 2 is 16, 7 is 23, 2 is 25, 7 is 32. Here, how much? 9 and 8 is 17, 7 is 24, 3 is 27. So it's not balanced, so I need to add an extra week, week 5. To balance, I need to add another 500. And when anything goes into week 5, or you can call it a dummy, then you should not increase the cost in week 5. In that, you should only increase by 0. And you have to solve this matrix. Once this matrix is made, the sum will be solved. Did you understand? The main thing is that week 2 will start from week 2. Week 1 will start from week 1, week 2 overtime from week 2, week 3 from week 3, week 3 overtime from week 3, and week 4 from week 4. And these dashes that you put are prohibited. It means there will be no allocation here. Here, M will come. Wherever it is prohibited, there will be M, and once M is set, it will always remain M there. Its value will never be changed or tampered with. Now we have to solve this entire sum. How? By using the transportation method. Now, it is not clear whether this is a transportation problem or not. This is the trick of this sum. The matrix for this was a dangerous one. It was this one. Now, it is not clear whether this is a transportation problem or not. Yes, how do we know that? It becomes clear because the rows have certain quantities, the columns have certain quantities, there is demand and supply. That's how we understand it, there is no other way. In between, the cost per unit is given. The hints for this are given here by making a matrix, and then its final answer is also given. So, we have made the matrix. You have also understood what needs to be done, right? Alright, sir, how did it click for you that it should be done this way? Because we have done all this before, that's why it clicked. If I were a student like you seeing this for the first time, I couldn't have done it either. The point is, I didn't solve this before class. Earlier, I did similar sums, so by looking at it I understood it was that kind of question. Alright, whether you produce in a particular week, you should sell it that week or the next, so that's how the flow works. If it's overtime, its science cost structure is different, so put that in a separate row. Since all this has been done before, it clicked, and for every science, what is our objective? Cost minimization. So, every cost has its own significance, so how will that cost significance be created? By giving a separate row and column and a separate space for that cost. When we do linear programming, variables are used to represent each cost. But when we do transportation, we create a cell to represent each cost. That's why we had to make a separate row and column for it. Alright, so you have understood this. You have also understood how to handle this. We haven't solved the whole thing. But we have understood one part. Now, there is just one thing left between us. Sir, please complete this one so that our mind can open up. What will all the steps be like? We will do it. While doing that sum, it will be better if we pick one with degeneracy. That is question number 7. We will solve that entire sum. But if you really want to benefit from this in the real sense, that I will solve question number 7 for you and you will gain from it, then first I would like you to try as much as you can on your own, whatever you have understood so far, whatever you have studied about transportation, go as far as you can without looking at the solution first and then do it along with me. Otherwise, if you do it directly with me, you might get confused because my speed is quite fast and you will feel like you are not able to do anything and you won't even realize where exactly you are lacking. Because if I make you do it and by chance you match my speed, then everything will go right for me in the flow, and for you as well, everything will seem to be going right. So you won't even realize where you could have made a mistake, and then you'll say, now I don't have that much time, so how will I give this exam? Even if you watched this video on the very first day of the exam, you will still have to solve this sum by yourself. On the first day before the exam, you should solve at least one question from each chapter by hand, and especially for QT, it's a must. Otherwise, it just won't click for you in the exam hall, no matter how easy it seems. like one sum from transportation, one from assignment, one from simulation, one from learning curve, then one from crashing, one from PERT, one sum on float, one on updating of network, okay, one question from maximum minimum, one from forecasting. Like this, you will have to solve at least one question from each topic. You have to bring yourself to at least this level so that after that you feel confident you will score 100%. Till then, keep practicing and try to solve everything completely. If you give that much time, the work will get done, so this is how to revise all these chapters. Solve one sum and for the rest just see what special things have come up. As I have already shown you the special points for the rest, I will make you do one sum. You do it first, then I will do it. Pause the video and solve it. Okay guys, now we are going to do illustration number 7. I will make you do the entire thing in full detail so that you understand all the steps of VARM, the optimality test, degeneracy, and even how to find an alternate solution, alright. So let's start. First of all, check what the objective is in the question. What is the first rule? To see what the objective is in the question. If you can see our objective, it is to minimize the total cost here. If it was a maximization problem, then you would first have to create a loss matrix from the profit matrix, and only then you could solve it. But first of all, our duty is to always check whether there is balance or not. First, check if it is balanced. Then, see if you need to create an opportunity loss matrix. When balancing, dummies are added and the dummy value is 0, so 0 goes in the cost matrix. If it's a maximization problem, 0 is also entered in the profit matrix. So, add the dummy and balance it first, then create the opportunity loss matrix and proceed. If it is a maximization problem, and if it is a minimization problem, then what will you do first? What will you do first? You just add the dummy, you will balance it with 0 cost and then proceed. So in this question, you see there are 3 plants. Wherever it is written plant, it will be a plant and there are 4 distributors. The capacity of the plant is given. The requirement of the distributors is given, so add all 3, 80, 50 and 90, how much does it come to? 220 and here 4, 4, 8, 4, 12, 5, 17 and 9. How much does it come to? 4, 4, 8, 5, 13, 4, 17 and 8, 25, it comes to 250. So, looking at it, we can see that there is a shortfall in the plant's capacity, so we will add a dummy plant and keep its cost as 0. If this was a profit matrix, we would have made the profit 0 and added the dummy first. After that, we create the opportunity loss matrix by making the loss matrix from the profit matrix and proceed. Since this is a cost matrix, we will move ahead directly from here. Alright, so my suggestion is that you watch carefully as I solve this and actively participate in the calculations by saying out loud what you are understanding. If you try to copy along at the same time, you might miss out on writing or understanding something. So, in the pre-initial check, I have already written that the capacity is this much and the requirement is 250, so it is unbalanced. To balance it, we will add a dummy plant. The capacity of this dummy plant is 30 units and the cost per unit is 0. So, the question never mentions which method to use. Usually not mentioned. If asked for final solution or optimum schedule, method not specified. If told to use northwest corner rule or least cost allocation, only initial solution found. Another name for the initial solution is the basic feasible solution. Normally, we don't use that term in class. But the initial solution is also called the basic feasible solution. If nothing is specified, then we always prefer the initial solution using VARM for the initial solution and basic feasible solution. Initial solution and basic feasible solution. Alright. Using VARM. Initial solution and basic feasible solution using worm. So, we will prepare the format. Plants X, H, Y, Z and here for distributors A, B, C, D, and we will add a dummy. Five, 8, 6, 6, 3. We have to write the cost here 5, 8, 6, 6. A, B, C, D, and they are also there. Okay. See, just watch how Sir is doing it. 5, 8, 6, 6, 3. The cost is written in short. What comes next? 4, 7, 7, 6, 6. 4, 7, 7, 6, 6. What comes next? 8, 4, 6, 6, 3. 8, 4, 6, 6, 3. And what about the dummy? 0, 0, 0, 0, 0. Here there will be availability, here there will be requirement, here there will be availability, here there will be requirement. Alright, so regarding availability and requirement. We will write 80, 50, 90 in big letters. Here 80, 50, 90 and for the dummy 30, 30. Then 40, 40, 50, 40, 80, 40, 40, 50, 40, 80. So now, based on this, we are going to arrange the format for win-win. Keep the space here for the penalty. This space has been kept for the penalty. Alright. So you should make a format like this. Write the value small inside, big outside. No need to use both blue and black pens in the exam. You can use one color throughout. You don't need to use both blue and black, but you should write small and big values accordingly. What does penalty mean? We will go through every row and column. We will go through every row and column. Take the smallest and the next bigger value and write them outside. The smallest is 3, the next bigger is 5. You will write those outside. The smallest, the next bigger, and their difference. The smallest, the next bigger, and their difference. If you get to smallest values, that is, if there are two values equal to the smallest, then the difference will be 0. Now look here, 4 and 6, the smallest is 4, then 6 is 2, then the smallest is 3, the 4 bigger than that is 1. What comes next? 0, 0. All are the smallest. 0 and 0, so it will be 0. Now, we will go through each column and write its penalty. The smallest is 0, next bigger is 4, so it's 4. Next, from 0 to 4, we get 4. Then, from 0 to 6, we get 6. Again, from 0 to 6, we get 6. In the next one, from 0 to 3, we get 3. Alright, now among all these, we will select the highest penalty, so the highest penalty we got is 2. There is a tie in this as well. In this penalty, whichever one we select, we circle it, and then inside that, the least cost. If you see, the least cost is also coming as 2, 0 and 0. Which one is the least cost? It is coming as 2, 0 and 0. So among those two, whichever has the least cost. Suppose if here it was 0 and here it was 1, then 0 would have been selected. Out of these two, on a combined basis, whichever has the least cost, that one has to be selected. So, on a combined basis between these two, which one has the least cost? Both are 0 only. On a combined basis between these two, which one has the least cost? So both are 0, so the least cost is 0. So if only one gets selected, then we select just that one. But right now, two have been selected. If two are there, then whichever among the two can take the highest quantity, we will give that. Like here, how much can go? Between 30 and 50, it's 30. Here, between 30 and 40, it's 30 from both. If it's from both, you can select either. Suppose I selected this one. That's it, you just had to select any one as per your choice, and that's done. Alright, and after selecting this, the adjustment outside will be that 30 will be deducted to make it 0, and from 40, 10 will be left. Okay. Now it's better if you listen to the whole thing. If you listen carefully to what I am explaining, you will understand it better. So what does the process say? First, make the format, then calculate the penalty. Calculated the difference penalty. Alright, try to understand the process. After calculating the penalty, you have to select the highest penalty. If there is a tie for the highest, then you have to select all of them. A tie can happen here, so if there is a tie, you have to select all. Then, going inside, you have to pick the least cost. Now there may be a tie in least cost. So, if there is a tie in the least cost, what should you do? The one with the higher quantity will be selected. Then, in the least cost cell, you have to allocate the possible quantity. Allocation is always the lower of demand and supply. After allocation, you have to make the adjustment outside. You have to adjust by subtracting the availability and requirement so that only the remaining amount is shown. Now, you just have to keep repeating these 5 steps until everything is done. Alright, so this part is done now. Once you reach a point where 0 comes, you strike it off or hatch it off there. Suppose you have struck this off. Wherever 0 comes, you strike it off, right? Wherever 0 comes, you strike it off. Is it okay? Next, there is a shortcut. Wherever 0 comes, you can just put a dash outside and you can copy the penalties above it. Now, whatever came in this row, you copied it above. You put a dash here because there won't be any further working for this, and you copied what's above it 2 for 2, 2 for 2, 1 for 1. You can do it like this. Otherwise, if you want, this can be done again. Alright, wherever there is a 0, if possible, you can copy around it. But for the opposite side, you will have to do the entire working again. Which is again, the smallest value is 4, then the next bigger one is 5, so the difference is 1, 4. The next bigger one is 7, so the difference is 3. Then, is there a bigger one than 6? 6. There are 2 6s, so the difference is 0. Again, 6 and 6, so 0. Then 3 and 3, so 0. When you get the same value twice, put 0. Now, among these, which is highest? Find the highest penalty. The highest penalty, this one, is only 3. Among these, there are 7, 3, 2, 5 on this side and 3 values on the other. Of these 8 values, the highest is 3. Go into the list of 3s and see which one is in the list here. So, how much can go on this? In the list of 90 and 40, 40 gets cancelled and becomes 0. 90 gets reduced to 50 if 40 is cancelled and becomes 0. If 40 gets cancelled and becomes 0, then it's finished as well. Alright, for whichever is finished, put a dash below it, copy the rest, and you'll have to do this side again. Lowest is 3, next higher is 5, so 2. Lowest is 4, next higher is 6, so 2. Lowest is 3, next higher is 6, so 3. What does our intuition say? Give two sixes together and make it 0. You should not do that. You have to make it 0 by giving two sixes. You should not do that. You have to take the lowest and the next higher one. From 3 and 6, we are getting 3. Alright, so from all these, pick the highest one you get. 3 will go into 3. What is the lowest among all? How much can go from 3 to 3? 50 will be cut by 50 to make 0, 80 will be cut to 30. So wherever a new 0 comes, we will strike it off. So this is finished. Shall we move ahead? Where did the new 0 appear? It appeared here on the Z row, so we will come out here and put a dash. The rest of the copy will hit to 2 dash dash. We will have to do this side again. From 4 and 5, 1, then dash. From 6 and 7, 1. From 6 and 6, 0. From 6 and 3, 3. So among all these, the highest is again 3. Now, within 3, what is the least? 3. How much can go on 3? Compare 30 and 80, 30. Subtract 30, get 0. Subtract 80, get 50. So wherever 0 has come, you will strike it off. That means he has been struck off, and here below, a dash is written, then 0, 1 dash dash, dash 1, 1 dash 1 0. Now come over here. The difference between 5 and 6 is 1. The difference between 4 and 6 is 2. Here, a dash, here, a dash. Alright, so which is the highest right now? In 1, 1, 1, 2, the highest is 2. So, within this 2, what is the least? 4. Within this 2, the least is 4. So, what will go on 4? 40 and 50. For 40, cut 0. For 50, cut 10. So here, 0 came, and here, this also got cancelled. Alright. So, wherever a new 0 has come, we will write a dash below it, then another dash. This is copy 1, this is 0, this is dash, and here 0 and 1, dash dash. So now, if you see, the highest is 1, and here also 1, so we will go inside both of these. Even if you look at the least from this one, you are getting 6, and if you go inside this one, you are also getting the least 6. So the upper 6 is going to 50 and the lower 6 is coming to 10, so I will select whichever is higher. The higher one is 50, so I will select 50. By selecting 50, this got cut and became 0. This got cut and became 0. It became 0 on both sides. It became 0 on both sides and this got struck off. Then this side also got struck off. In the end, 1 6 was left. The remaining 10 will go here, so this 10 is cut to 0, 10 is cut to 0. Whenever something like this happens in any allocation, where both sides get cut and become 0, understand that this case is indicating degeneracy. What is degeneracy, sir? You haven't told us that yet. Let me explain it now. Now, basically, we have to do the optimality test for the initial solution. Here, when all the allocations get cut and become 0, it means the allocation is complete and the initial solution is finished. Now, we have to do the optimality test. Before the optimality test, the golden rule says that you should do a pre-optimality check. The golden rule says that you should do a pre-optimality check. And how is that done? M plus n minus 1. M plus n minus 1 means M stands for number of rows. How many rows are there here? 3 and 1, that makes 4. N means number of columns. How many columns are there? 1, 2, 3, 4, 5, minus 1. So this comes out to be 5, 4, 9 minus 1 over 8. Then this is the number of allocations. If you count the allocations, how many are there? 1, 2, 3, 4, 5, 6, 7. So the number of allocations is 7. If this matches, then we call it non-degenerate. If it doesn't match, then we call it degenerate. If it becomes degenerate, it means that if you do the optimality test, it won't be complete, it won't be proper. The U plus V matrix will not be formed correctly. So for this, you will have to make up for this shortfall. So, how do you remove degeneracy? You will bring in a new allocation. Since the allocation was less, a new allocation will be made. Inserted. Where will we insert it? At the minimum possible cost, comma, which separates items and unallocated an independent cell that has not yet been assigned. There will be 3 criteria, only then a new allocation will be made there. What will that new allocation be? The new allocation is E. This is also called epsilon. The value of E is close to 0. It is assumed that it is nothing but 0. So, to remove the degeneracy, a new allocation will be inserted at the least cost unallocated independent cell. Alright, so now we have to find out which one has the least cost in this. Here, which one has the least cost in the entire table? The lowest seems to be 0 only. So, if we pick from the 0 cell, we need such a cell which should be unallocated. So, they see an unallocated 0, all these empty zeros, but there should not be a loop from there. Independent cell means there should be no loop. There should not be any loop formed from there. What is a loop? A loop means such a diagram that if you start from a cell, you can go around through the quantities and come back to the same cell. That is called a loop. For example, if you see here, if we start from here, you can turn at the quantity above. You collided here and then you can turn. You collided here and then you collided here and then you are not able to come back. If you go around and reach here or go up, you are not able to come back. So here, this appears to be an independent cell. But is it really independent? Let's check it. You went here, then turned right from here. From the right you went up, and from up you came here. From here, if we come back down, we are still not able to return, so this is also not allowing a loop to form. Even here, in the adjacent 0, a loop is not forming. If you pay attention, even in the adjacent 0, a loop is not forming. Alright, now see, even here a loop is not forming. If you go from here, then here, then here, you can turn here. But we are not able to return to the place where we started. If we are able to come back, then a loop is forming there. If a loop is forming, it means that is a dependent cell. We need independent cells. Alright, let's look at this 0 here. Let's look at this 0, the first one. If we go here, then here, then here, we are able to come back. See, by moving around the quantities, we are able to return, so a loop is forming, so this one is rejected. But there is a tie between the second and third. We can select any one from these. This one, and this one. Couldn't come back after turning around. Alright, and if we go from here, go up, go this way, still we can't come back. Again, even from here, a loop is not forming. Tap, 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 tap. Even from here, a loop is not forming. See, since a loop is not forming from 2 places, we will have to select any one. Suppose we have selected this one. We will have to select at least one. Which is, we have selected this one. This one is Z, for instance. So, we have selected one place. Now the degeneracy has been removed. Now, for the optimality test, we make two matrices. We are going to make those now. And which matrices are those? One is the U plus B matrix and the other is a delta matrix. This sum here is a 4 by 5 sum. Accordingly, we will have to make sales. 4 by 5, 1, 2, 3, 4, 5 are 1, 2, 3, 4. Sir, do we have to make it like this in the exam as well? Yes, you will make it with a pencil. Sir, what if we don't make it? If you don't make it, there could be a mistake in the sum itself. The chances of making a mistake will increase. Then we'll make it, sir. Very good. Good boys, good girls. If you make it, then U plus B matrix will be formed. Here, you will write the U values. You will write the V values. The U plus V matrix says that for whichever cells you have allocated, bring the cost of that cell. Like dash, dash, 6 dash, 3. We said dash, dash because we don't need their cost. 6 dash, 3 dash, dash, 6 dash, 3. So for those, their cost is dash, dash, 6. Or this has gone wrong. Here it is 5 and below it is 4. One section has become less. Alright. M means the number of rows. N means the number of columns. So there are 1, 2, 3, 4, 5 columns. I'll write it here as well. So dash, dash, 6 dash, 3. Okay. A separate space has been kept outside for you with dash, dash, 6 dash, 3 done. Dash, dash, 6 dash, 3. What comes next? 4 dash, dash, 6 dash. 4 dash, dash, 6 dash. 4 dash, dash, 6 dash. What comes next? Dash, 4 dash, dash, 3. Dash, 4 dash, dash, 3. What comes next? Dash, dash, 0 and 0. Dash, dash, 0, 0. Dash, dash, 0, 0. Is it okay? So this is the first step of the U plus V matrix. That first, what will you do? Sir, you will copy the cost where there was an allocation. Then we will cut off his head. What kind of mischief is this, brother? First you write it, then you cut it off. Yes, this is the system. We write it, then cut it off, and in the delta matrix we strike it off. Wherever it is struck off, we are striking off the corresponding ones. Struck off, empty, empty. Struck off, strike, empty. Struck off, empty, empty. Struck off, empty, empty. Struck off, struck off. The logic behind striking off here is that wherever it is struck off, the answer is 0, so you don't need to work on it. It's struck off to save effort. Now what needs to be done? You have to remember one equation. According to cost equal to U plus V, you have to first take U co 0. We will always take U as 0 first. Let's fix this. If the question ever says to take some other value as 0, then you have to take that. Otherwise, we take U as 0 first and, following this equation, we will easily find the values of V and then the remaining values of U. There will be 3 or 4 more values of U. All the values of V will come. So, like here, the cost inside is the cost, and this is U, so what will we be? The cost given to U is 3. What will happen even if U are 0? So, the value of V will be 3. Correspondingly, 3 for V will come here. Now, in the same way, if it is 0, then 6, so here 6 will come. Okay, so this is the end of Geo's work. Now, if you get to below, then U will be subtracted from B. Now look, hold on to this B. If you know B, which is 3 Then this 3, suppose you want to find u. Here, you add 3 to 3. This is 3 in cost, so what will be the value of u? It will be 0. Here, what will be the value of u? It will be 0. Three minus 3, here it will be 0. Now 0 minus 4, here it will be 4. 6 minus 0, it will be minus 6. Minus 6 minus 0, it will be 6. Alright. Then from 6 and 6, here it will be 0. From 0 and 4, here it will be 4. Got it? So, once you work it out, it becomes clear. Here, I made 1 extra, didn't I? There were only 4 rows, but I made 5. That's why it's going black, so we shift its value upwards. 0 is cancelled, 0 cancelled. This needs to be reduced. Alright, that's why 1 is going black. There are 4, but actually 5, right? So its corresponding 1 is also cancelled here. Understood? Now, what do we have to do next? Now, this very equation is our support. Using this, we have to find the inner value. The value inside is called cost, and you have to add u and b. Like here, see what u is, look at the corresponding u on this side, see 0, and also look below. 4, so 0 plus 4 is 4, then 0 plus 4 is 4, then 0 plus 6 is 6. Then look below, 0 plus 4 is 4. Then look below, 0 plus 6 is 6. Then look below, 0 plus 3 is 3. Then look below, 0 plus 4 is 4, 0 plus 6 is 6, 0 plus 6 is 6. Then see, minus 6 and 4 gives minus 2, minus 6 and 4 gives minus 2, minus 6 and 3 gives minus 3. Is it okay? So the process is that first you have to copy the cost. Then strike it off from the top. Alright, copy the cost and strike it off. Then start by taking the value of u as 0, and by following this equation, first complete all the u and v values. Then, using these u and v values, calculate the internal cost. Now, go to the delta matrix. What the delta matrix says is that from the original cost given in the question, you have to subtract the cost you get by adding u and v. Only then will you get the delta. So if you look at both of these, both are 4, and here it is 5, and how much is this? It is 8. 8 and 5, so from 8 and 5, you have to subtract 5 and 8. 5 minus 4 is 1, 8 minus 4 is 4. Then for D, it is 6, so 6 minus 6 gives 0. Then below, let's go to 7. If it is 7, you will subtract 7 from 7. 7 minus 4 is 3, 7 minus 6 is 1. Then in the last one, it is 6, so 6 minus 3 is 3. Check if there are any unallocated cells anywhere. Then what is there? 4, so 8 minus 4 will give 4. Then it is cancelled. Then there is no 7 minus 7, then it is 6. In the Z one, it is 6, so 6 minus 6 gives 0. Then what? After the 6 1, again it is 6, so 6 minus 6 is coming as 0. Then what? Here it is 0, we can see 0 here. Everything is showing 0, 0, 0, so 0 minus minus 2 gives 2, 0 minus minus 2 gives 2, 0 minus minus 3 gives 3. So if this delta matrix comes out to be 0 and positive, then you can say the solution is optimum. We don't have to do any further work. If even one delta comes out negative, then we have to improve the solution. Let me explain once how to improve it. Suppose if minus 1 had come here, then as soon as minus 1 comes, we understand that further cost reduction is possible here if we allocate some quantity. Delta means that if even 1 unit goes here, your cost will decrease by 1 rupee.
So if the cost decreases, we will stop.
So if minus 1 had come here, we would have made a loop by marking a tick from here. So what is the system for making a loop? Wherever there is quantity, you have to go around and come back, and you have to finish where you started. For example, wherever you have marked, there is quantity, so you go here, then see where you go next, here, then here, then here, then here, but you are not able to come back from there, so a loop is not being formed from here. It means that allocation is not possible here, so normally in such a scenario, minus 1 will also not come here. So, minus 1 comes only at those places where a loop can be formed easily. Now, I will teach you that loop through an alternate solution. But let me also explain what an alternate solution is. But this solution has become optimal here because all the deltas have come out to be 0 or positive. So, if you want to conclude the optimum transportation cost, then what would be the optimum transportation cost? What will be the optimum transportation cost? The optimum transportation cost will be X, Y, Z. What all do you have to transport? Look at that. From X you are transporting to C and to E. From X you are transporting to C and E. How many units are you sending? You are sending 50 and 30 units, right? If you are sending 50 and 30 units, then what is the cost for that? It's 6 and 3. So, what is the cost per unit for this? It is 6 and 3. You will have to write this for all of them. You must already know how to write this, I guess. For Y, it is A and D. 40 and 10 are going from Y to A and D, 40 and 10. From Z, where are they going? From Z, we are sending to B and E. 40 and 50 are going to B and E, 40 and 50. And from dummy, where are they going? From dummy, we are sending to only one place, that is D, 30. Basically, dummy to E doesn't mean anything. From dummy, nothing is going to C. From dummy, it is going to D, that is 30. And we can write the cost for everything from here. The cost for 40 and 10 is 4 and 6. 4, 6. The cost for 40 and 50 is 4 and 3. And for dummy, it is 0. 4, 3 and 0. So, from this, the total cost will come, and this is the solution. Sum is over. Since D has gone to dummy, it means we have a capacity shortage. So you should understand that DS requirement will not be fulfilled by 30 units, okay? DS requirement will not be fulfilled. DS requirement will not be fulfilled by 30 units, okay? Now, there is one more extension to this question here, where it is asking if there is any alternate solution in this solution, then tell. In this, it is being mentioned in illustration number 5. Okay, he is talking in 5. We won't go into 5, we'll explain the alternate solution right here. When does an alternate solution exist? When any delta is 0. If any delta is 0, that means an alternate solution exists. Today, delta is 0, so an alternate solution exists. So what needs to be done to find the alternate solution? you have to make a loop from any delta that is 0. You have to make a loop from any 0 delta and find the new allocation. So suppose here at 0, we make a loop from here. See, from here it went this way, then this way, came down, then came here. Then I am not able to come back, so the loop is not being formed from here. You can only go where a loop can be formed. From here, you can go this way. This way, then this. Now, it is not necessary to go around from here. You can also skip the quantity and come back. So, from here the loop is formed. Alright, now you can try on all the other zeros as well. Whether a loop is being formed or not, it may or may not be, so I don't know. It's not necessary that it will be formed on all of them. Alright. See. Let's try on the next one. Will a loop be formed on 0? Let's see if a loop will be formed on this one. Let's see from where to where we can go around. Up to a point, you can go around, but if you skip here and try to go up, you won't be able to, so you'll have to go around from here itself. The way to go around is to the right, but if you turn right, you can't come back, you get locked. If you go around here, then you can go up, you can come down, but if you come down, you get stuck. So here, delta is not coming into the loop, this one is not coming into the loop if you go from below. We'll have to look for some other way. If you go this way, you can go up, you can come down. Going round and round, it's not matching up. Went this way, went up, went this way, came back here. A loop is formed. So, a loop is being formed from this as well. Let's try from this 0. See if a loop is being formed from here. This should be easy. Went this way, went that way, went this way, it's not happening. Not able to return. Alright, so after going up it didn't work. Went down, went this way, went that way, went this way, went that way, and came back here. Came back, which means a loop is being formed, that is, a loop is being formed from all 3 zeros. This means that any of the 3 deltas can be selected to find an alternate solution. Suppose I select this one itself. See from where the loop was formed and came back, went this way, went up, went this way, went that way, went this way, and came back here. A very amazing loop has been formed. So, where the loop is formed, normally remember, at the corners of the loop, the quantity is allocated where we make the bend. Now, from this, we have to find the revised allocation. How do we find the revised allocation? Add a plus at the starting cell, meaning we have to put something here and then subtract at alternate bends. Minus here, minus here, minus here. Sorry, let me do one thing. I wrote minus here. Actually, it would be better if I show this in a separate matrix. We will find it by way of a separate matrix, the loop matrix, and what do we call it? Reallocation. It is better to show the new allocation using a separate matrix. There, it's getting a bit messy and the quantity is also not shown. So, this is a 4 by 5 matrix. 1, 2, 3, 4. 1, 2, 3, 4, 5. Once again. 1, 2, 3, 4, 5. So according to this, look here at the loop matrix. It is saying that you should copy your last allocation, the last allocation quantity 50, 30, blank, blank, 50, 30, blank, blank, 50 and 30. Now, then, 40, blank, blank, and 10, 40, blank, blank, and 10. Then blank 40, and blank, blank, 50. Now blank 40, and blank, blank, 50. Then blank, blank, E and 30, blank, blank, E and 30, blank, blank, E and 30. Now, wherever there is a 0, we will make a loop from there. So here there is a 0, so I will make a loop from here. Now, suppose this does not come out to be optimum. For instance, this part is not optimum and there is some negative value here, then we make a loop from the negative 1. Now, even among the negatives, there are many negative values, so what do we do? So, we make a loop from the one which has the highest negative value. We make a loop from the one which has the highest negative value. Now, a loop will be formed from here and it will move forward. By rotating around the quantity, we will make a loop and come back. Turned here, turned here, turned here, turned here, turned here, and came back here. So, to make a loop, remember this, we copy the quantity and we also copy the quantity in the relocation matrix, but not the cost yet. We write the cost only in U plus B and delta. Here, the cost is used there, and here, the quantity is used. And where the loop started, you will put a plus sign there. What will you put there? A plus sign. Where the loop turns, put a minus, then alternatively plus, then alternatively minus, then alternatively plus, then alternatively minus. So, plus and minus go alternately. This means that if you add something here, you will also have to remove it from somewhere else. We have already done the allocation and made everything 0. Everything has become 0, so if you want to put something here, from where will you take it? If you have to put something somewhere, you must take it from somewhere else. That is why the loop is used. Now, where there is a minus, look for the smallest one. See where there is minus 50 again, then 30. Among the 3 cells with a minus, the smallest is 30, so let's adjust everything by 30. Adjust everything by this 30. Just adjust everything by this 30. Wherever you have put minus and plus, adjust everything there and work out the new revised allocation. So here, simply 50 minus 30 is coming as 20, just 30 plus 30 is coming as 60, then comes 40, then dash dash 10, then 40, then dash, then 30, and 50 minus 30 is coming as 20. Then here, 0 plus 30, E plus 30 is basically 0 plus 30, so 30, and 30 minus 30 cancels out, so don't write 0. Write a dash here. If you write 0, then the counting will increase. Now, if you do the optimality test here, the answer will be the same as before, all right. This will also pass the optimality test. You will get delta as 0 and positive here as well, and it will give the same answer because here you have rotated with 0 delta. If we had any negative value here and made a loop out of it, then when we did the optimality test, there might have been some delta 0 and positive there. Alright, that would have been a better solution and the cost would have been lower. But right now, its optimality test will give 0 and positive. This is not required here. Why? Because we have to find the alternate solution. We already know that this will be optimal. So, when do we need to do the optimality test for this? When we are working with negative delta, and if you check your optimum transportation cost with this, it will be the same as before. It will be the same as before. Alright, we can check its cost from the question itself. This quantity has already come before us. Did you understand anything? So, is it clear what loop matrix and reallocation matrix are? Alright, very good. I hope things are clear to you to a large extent. It is possible that your expectations were a bit higher. But from my side, I have done even more than what your expectations should be. But if your expectations are even higher, then for that you will have to come to the main class. For now, even this much is enough for you. My recommendation is that you try to solve this sum again on your own without looking, or pick any one sum and try it. Maybe you can pick up this profit matrix sum and try to solve it, see if you are able to do it or not. In fact, set aside a question like this for the day before the exam as well, and check if you are able to solve it or not. Alright, the SCM DGB book that we are providing you in soft copy, for that soft copy you will need to join a notes group. You will have to join that group. The link for it will be available in this video. Okay, and our students will get it in the class notes drive. So if there is any transportation question in that as well, make sure to practice it. Just looking at the solution won't help you pass. You will have to do it yourself. There will be a few hurdles. You might feel a bit confused about what to do in a time. So maybe there will be one extra iteration or one extra adjustment, but you will get your answer. If there are more adjustments, it doesn't make any difference. Many times in a tie, you are told to select either one, but if you select the opposite, it might just take one extra iteration. But ultimately, the answer will be the same as it should be. Alright, there is no problem if there are more iterations. So, the advantage of all these things in the exam is that nothing too complicated comes up. But you have to keep in mind that you have limited time allotted according to 1.8 marks per minute, so you have to solve the sum within that time, which means you need to have speed in your hands. If you are doing it very slowly and dragging it out, then it will not be possible to get the full marks for this. This can also eat up your time, so only those who are fully confident should attempt it in the exam. Brother, it's not like you don't know it at all and still try to forcefully attempt it. Alright, with this, my discussion on transportation comes to an end. But now you should practice MCQs and try to solve a sum on your own, or you can redo the sum that we have just done. Alright, very good.